Good morning, sir. Tejas Badrinath, sir. Mr. Tejas. Are you there, sir?
Yes, sir, I'm there. Good morning. Good morning, everyone.
Okay, sir. So, I am Ram Naidu, Dr. Ram Naidu.
All
So,
right, sir.
today I am the host. Okay, sir. So,
Okay, sir.
if you have any problem, just inform me, sir.
Definitely, sir. Sure.
So, first, already my colleague Dr. Rasekar told you, sir, that beginning at the beginning of the session, so some dedication is there. So
Okay.
after that, we have to introduce yourself, and you continue. You can continue your talk, sir.
All right, sir.
So meanwhile, would you like to check your slides, sir?
I'm sorry.
So do you want to check your slides? Means showing slides.
Yes. After my introduction, I will be presenting my screen to you so that we can start the session from there on.
Okay, sir.
Sir, let me know when I can start, sir.
Okay, sir. Just after 5 minutes, sir. So after dedication.
Sure, sir. Okay.
Uh, okay. Sharing. Unmute చేయడం. Good morning to all, and today our speakers, Mr. Tejas and Mohan. So they are going to give a talk on introduction to industrial robotics with SRC. So before this starting talk, so some dedication is there. Okay, so this today's session is dedicated to Yallapragada Subbarao. So let me give a brief introduction about him. Subbarao was born in Bhimavaram, West Godavari district, Andhra Pradesh in India. He passed through a traumatic period in his schooling at Rajahmundry and eventually matriculated in his third attempt from the Hindu High School, Madras. He passed the intermediate examination from the Presidency College and entered the Madras Medical College, where his education was supported by friends and Kasturi Suryanarayana Murthy, whose daughter he later married. So Subbarao was a pioneering Indian biochemist who discovered the function of adenosine triphosphate (ATP) as an energy source in the cell, developed methotrexate for the treatment of cancer, and discovered a broad spectrum of antibiotics, tetracycline and chlortetracycline. A student of Madras Medical College, his elder brother and younger brother both died due to tropical sprue in the span of 8 days. He subsequently discovered folic acid as a cure for tropical sprue. He discovered methotrexate, a chemotherapy drug still used today. Most of his career was spent in the US, and despite his isolation of ATP, Subbarao didn't gain tenure at Harvard, though he could lead some of America's most important medical research during World War II. He is also credited with the first synthesis of the chemical compounds folic acid and methotrexate. Following Gandhi's call to boycott British goods, he started wearing khadi surgical dress. This incurred the displeasure of MC Broadfield, his surgery professor. Consequently, though he did well in his written papers, he was awarded the lesser LMS certificate and not a full MBBS degree. Subbarao tried to enter the Madras Medical Service without success. He then took up a job as a lecturer in anatomy at Dr. Lakshmipathi's Ayurvedic College at Madras. He was fascinated by the healing powers of Ayurvedic medicines and began to engage in research to put Ayurveda on a modern footing. He promise of supporting from Malladi Sachalingam Naikar charities in Kakinada and financial assistance raised by his father-in-law enabled Subbarao to proceed to the US. He arrived in Boston on 26 October 1922. He developed a method of synthesis folic acid, vitamin B9, based on work by Lucy Wills to isolate folic acid as a protective agent against anemia. After his work on the folic acid and with considerable input from Dr. Sidney Faber, he developed the important anti-cancer drug methotrexate, one of the first cancer chemotherapy agents and still in widespread clinical use. Subbarao also discovered the basis for etrogen, which was used by the World Health Organization against filariasis. Subbarao died in the US due to cardiac arrest. So with this brief introduction about Yallapragada Subbarao, this section is dedicated to him. And now I am handing over to the session to Mr. Tejas. Sir, to introduce yourself first and then continue the session, sir.
Yes, sir. Thank you, sir. I'm Tejas from Stobly Robotics. So I work here as a business development executive into robotics applications. So first of all, I would like to thank Viresh sir and the team for giving me the opportunity to interact with young students like you, and to give you the knowledge of industrial robotics and to help you understand what we are doing here in industry and what new technologies are coming up, and also to educate you and guide you to industrial robots. I will go through my presentation. Sir, I'm not able to share my screen actually.
Just 1 minute, sir. 1 minute.
Right,
We
all
are
right,
making, we are making as a making you as a presenter, sir. Just one.
all right. Uh,
Now
Right.
check.
So, yes, I'm able to share the content. So, I just want to understand from the students that what do you guys know about industrial robot? So, have you seen anything as such in videos, or have you seen in any exhibition events, or have you seen something robot do something which you thought, okay, this was not possible? Anything, guys, anything which you can interact? Hello, guys. You can interact. So this is just a normal interaction session. So I'm not going to be talking anything advanced or something. So right, you can just speak up. It's fine.
Excellent.
Right. So anyone can speak of what you have seen. I'm getting messages actually. Right. Glass factory, robot film. All right. Space station. Okay. Right. Okay. So only in TV and videos. So okay, any of you guys have seen in person in exhibitions? So have you seen any robot doing any applications as such? Okay, okay, all right. So I'm getting lot of no's in hotel. Where have you seen? Yeah. So I mean, it's not the vacuum bots or sweeping bots as you mentioned. Right, right. Roombas. What's that, Adarsh? Okay. Uh, right. So assembly line, fine. Uh, right. Serving robot in hotels. Right. So see, I just want to tell you, robots can be used in different applications, right? So that there are different type of robots. So there are medical robots, there are pharmaceutical, there are industrial robots. As you say, there are vacuum robots. There are robots which can bartend. There are robots which can vacuum. There are robots which can cook food. Uh, Yes. So I'm getting a lot of messages. Good here. So metal ingot, spot welding, spot the dog. Right. So that's a different part there. What spot the robot dog? Okay. Hello. Am I audible, guys?
Yes, sir. Yes, sir.
Yes. So I will share you my screen. So let me go through what industrial robots are and what we as Tobly do in general. Right. Just a second. Yes, so you're able to see my screen?
Yes, sir.
Right. So yes, so Stobly is one of the top 7 robotic companies in the world. Ma'am, I would like to mute yourself. Okay, thanks. Yes, Stobly is one of the top 7 robotic companies in the world. So Unimation is the first robotic company which manufactured robots. So that is the first company in the whole world So who started manufacturing industrial robots? So that company was Unimation. So what they did was they had a four-axis arm, so which they had given for General Motors, as you know before. So it was a merger between Edison Electric and few other companies, which then became General Electric. So Thomas Alva Edison, so so the inventor. So that company merged and became General Electric. So then for General Electric, the Unimation company had provided robots for welding in their car assembly application. So that is the first instance of a commercial robot which has been applied to manufacturing or a production industry. So in a production line. So from there, the technology started to develop itself, and then and we are here right now. So that Unimation robots first into welding, and then it's into gluing, and then few other assembly applications. First it started as a four-axis robot, and then from there the technology had been making across the whole world. So then the technology reached Japan, where few companies in Japan, Korea, and also from China had invented robots. So the parent, the first company was Unimation, and now in recent 90, I mean in early 90s, the Unimation company was acquired by Stobly. So Stobly is our company, and Unimation was acquired by Stobly. So the first robot manufacturers in the world was acquired by Stobly because of its huge technology development. The word R&D was there at 1800s as well in terms of robotic applications into production line systems. So we acquired the Unimation, and that became one of the biggest acquisition of Stobly's history, where we had developed new softwares. We had developed six-axis robot arm for other robotic applications. So let me go through what we do in general. So Stobly is a Switzerland company. So I'm Tejas. So I'm a business development executive, and I have 4 years of experience. And yes, I've done my masters. Uh, we as Stobly are into three products, so which is robotics, textile, and connectors. So in connectors, there are two subdivisions, which is fluid connectors and electrical connectors. So fluid connectors is the where it you can call it as couplers, you can call it as connectors. So yes, so that is it. So our uh, I would like someone to mute. So Mr. Praveen Jayant, please mute yourself. Thank you. Yes. Connectors, we have fluid connectors and electrical connectors. So electrical connectors. Yes. So these are the two product line in our connectors. So you can see different type of electrical connectors technology into multi-lamp and other different technologies, and robot and textile. So Stobly started doing textile business in 1800s. So our inventor Stobly and Rudolf Redding. So had invented the textile. So yes, this is just a short video. I hope you can see the video. Yes, this is the first Horgen is the city in Switzerland. So yes, 1946. This is a textile machinery. Yes, in 1956, pneumatics and hydraulic. Yes, in 1989, acquisition of Unimation. Yes, in 2002, we happened multi-contact, so one of a major electrical connectors company. And today, yes, so we are into 29 countries. So we have a representative in 50 countries, and we have more than 5,000 staff. Yes, so Sobly Robots has 125 years of innovation. So we have different type of robots, starting from four-axis robot to a six-axis robot. So just tell you, 4-axis is a SCARA robot, which we call, and the 6-axis we call it as a articulated arm. So 4-axis robot payload can start from somewhere around 1 kg payload, and we have payloads of up to 150 kgs for the 6-axis robot. And yes, our robots can be used in different environments, which I'll be taking it to you further. And so robotic application, generally what people think of industrial robots. So I'm not sure how many of people know about industrial robots. It's not the robots what you see in movies, which is artificial intelligence with things which moves. So robot is just a articulated manipulator, articulated arm or a manipulator, where it is programmable and can be flexibly deployed to any manufacturing or industrial applications. So on this, so we robots can be used in different applications where it is difficult for humans to handle hazardous applications or clean room environment where you need high speed and high accuracy, or where you need the robot to work 8 hours or 10 hours, where operators will need to take a break, so where it affects the productivity, or in terms of where you want the robots to handle in a food grade environment where a human touch or where a human's touching the food will be a contamination for the food. So robots has a food grade capacity, and it is manufactured with food grades oil, and also it can be washable as well. So once it is after, before and after handling of food applications, can be used in food, and also into electrical and electronics. It is also used in assembly, pick and place, sorting, welding. So it can also be done in electrical and electronics also, and also into chip manufacturing as well. And in terms of aerospace, yes, we can do it in aerospace. So aerospace applications are manufacturing, polishing of turbine fans, and also assembly of aircraft engine is complicated because it needs different elements to different parts. So we've not done something in aircraft manufacturing, engine manufacturing or something. So we've done parts assembly also, not a engine bigger part assembly or smaller part assembly, and also module manufacturing also we have done in that. And we have done in pharma and life sciences. So in pharma, we have done in solid drugs, in liquid drugs, lyophilization, and also into production of vaccines, where it is required a clean room system and clean room environment robots for handling photovoltaics. So photovoltaics and PV industry is a complicated industry where the wafers and silicon wafers manufacturing for the solar cells is a little complicated. The solar wafer cells are very thin, and it's modular, and it's very lightweight, and also it is ductile in its property, where the robotic application it handles with care, and where manually you can see there is lot of breakage in the cell, I mean in the wafers, in terms of processing the silicon wafers. So we've done in plastic industry and textile and many more. See, I would say the robotic technology is just limited to our imagination and capability. So that is what I think. So proceeding further, so I about the products, I just give you a short presentation, nothing much into details of what our products are. So yes, so we have 4-axis and 6-axis robots. So it starts from our TS20 range, which is of 1 kg payload, and TP80, which is also 180 kg payload. So our TP80 robot is the fastest robot in the world, where we call it as a high speed and high acceleration robot. And also the robot arm is connected to a controller. So there is older generation and newer generation controller. So CS8C is the older generation controller, and CS9 is a newer generation controller. And in terms of 6-axis, we have TX240 and TX200L. So these are the ranges of robots what we have. You can see 2 kgs of payload from TX240 and 80 kgs to TX200L. So there is a difference between our robots to other robots in terms of payload. So there is only one payload in terms of robotics, but then we call it two payloads. payloads. So I would explain you that. So you can just take a robot TX240, which you can see in the bottom left corner. So the 6-axis robot, there is two payloads. So one is 2 kg and one is 2.3 kgs under conditions. So what this means is the robot can fully work in a high speed environment for 2 kgs payload. And if you want to load extra 300 grams of payload, then the robo speed reduces, where we call it the maximum payload and the nominal payload. Till the nominal payload, the robot can work in a high speed environment, and in the maximum payload, the robo will be in a reduced speed mode. This is to improve the gearbox and the efficiency, and also the motor efficiency, and also the capability of the gearbox. So we would recommend the customer to go for the nominal payload, where they can make the nominal payload as their maximum payload. So if you would have to stack the robot to a maximum payload, so then it will the life reduces for the robot. And yes, so every robot will be attached to a controller, and the controller will be attached to a teach pendant. So controller will be having three elements. One is the power system, the second would be the communication, and third would be the drives for the robot. And every robot, so assume either a 4-axis robot or a 6-axis robot. So you have you call it 4-axis because it has 4 joint movements, and in every joint movement you have a motor, you have a braking system, and you have an encoder to the absolute value where your motors are moving, so as to calculate that and receive the feedback. So we have an encoder, and also a braking system, and also a motor. So these are the basic elements in a joint. So in a 4-axis joint, so there are 4 motors. So I would explain it to you. I think I hope you can see my cursor, right? So yes, so the base is called the first axis, and this is called the shoulder. This is the second axis, and this up and down movement is the third axis. These are the 4 axes of the robot. So next you come to something called a 6-axis robot or a articulated arm. So when you call it an articulated arm, so arm is something which resembles human activity through our hand, right? So it mimics our human hand for operations. So with a programmable intelligence, and so this arm is a 6-axis arm. So where I can show you similar for that as well. So this is called the base, and just a second. Yes, this is called the base, and this is the shoulder. This is the elbow. This is the wrist 1, and this is the wrist 2, and the wrist 3 is the rotation. So it is 6-axis. So base, shoulder, elbow, wrist 1, wrist 2, and wrist 3. So these are the 6 axes for the industrial robots, any articulated arm industrial robots. And there is 7th axis robot as well, where we don't have it in our product catalog. So it is just a 360-degree motion of the shoulder or the elbow. So there is someone called Yamaha robots, where they have come up with extra positional rotation, where they call it as a 7th axis robot, where the maximum articulated movement for 3D accessibility, you just need 6 axis to do any application what you want. Right. So this is a standard range of clean room ISO class 5 robots. I'll just play you this video, so you will have an understanding of what robots are. Yes. So the controller powers the robot and the teach pendant, and the controller is connected to the socket. Yes, a controller has our all three products, which is variable assembly language, and SRS is the Solly Robot Suite software. So, which is the main theme of this introduction and also to our presentation. Yes, this is what our simulation software can do, which can program, which can simulate and check the environment of the robot even before deploying it to the customer facility. You can check the cycle time, you can check the speed, you can check the acceleration, you can check what can be, you can check everything what you want in our SRS software. And every motor is inducted, and also you can get the feedback, and you can also read the error logs where each and every errors are recorded and then rectified. Yes. So this ISO class 5 robot is a medical and pharmaceutical robot, where if you check for a ISO class 5 safety certification, you will know there are certain parameters where the robot has to comply to get this deployed in a pharmaceutical industry. So where our robot has complied to ISO class 5 for inducting into pharma applications. And yes, electronic environment, the robot, okay, so electronic environment, we can use it in either electrical or electronics in terms of chip manufacturing to other electronic equipments handling. So in terms of any electronic or electrical equipment manufacturing or assembly, so you will the operator, when they do things manually, they'll be using a apron, gloves, which is all EST protected, electrostatic discharge protection. So this EST protection is used to keep the chips safe in terms of manufacturing, so that it will not get short circuit. So this ESC robots, the thing which we have inducted in our robots are, the robot is manufactured in a ESG paint, right? So this ESD paint will not conduct the electrical and electronic, the electrodes, the electrodes. So then there is a white environment or clean room robot. So ISO class 2 is the higher grade of classification, where it is used for vaccine handling facility. In terms of grade of classification, where it is used for vaccine handling facilities. In terms of screen, so where you will be having a vial or PFS, which is called as a pre-filled syringes, or you have a bottle, or you have an ampule. So these are the injectables containers where the liquid filling will happen. So just in a similar environment, so washing of the washing and sterilization of the vials. Then after that, it goes for a filling. So then after filling of the vaccination, it goes for sampling, and after sampling, it again goes for packaging. So this is a general application of a vaccine handling facility. So vaccine handling facility comes up with the open wraps and closed wraps, where the environment is a controlled environment, where the air and water is in a controlled environment. Just give me a second. Yes, sorry guys. Yes, so I was in ISO class 2 certification where the air and everything has to be in a controlled environment so as to not affect the quality of vaccine production what we are doing. So this ISO class 2 can also, this robot can also be disinfected with isopropyl alcohol. So where you can use, so in a typical ISO class environment, the robo has to be in a sterile condition to start the manufacturing of in the pharmaceutical process. So before and after the manufacturing application, the robot is wiped or washed. So if it is wiped, it can be wiped with the isopropyl alcohol, or it can be done with a vapor hydrogen peroxide, which is just a similar disinfection application what we do for the safety of the productivity of vaccines. Right. So then there is a wet environment robot. This robot is of IP65 specification ingress protection, and our arm is IP69 rated, where our robot can use for washing applications. So in a typical washing applications, it can be used for washing of engine casing, where once the deburring happens or the home, whatever the deburring happens, so then there will be dust particles or elements which will be attached to the component, where our robo picks the engine component, and you will have a high pressurized water bath where the robot dips the component and washes the application, and after it's dried and all the dust particles are removed, then it goes for assembly automation. Am I not visible? I'm getting comments that I'm not visible. Right. Yes. And so these robots, the cabling of these robots are under this arm, whereas the cabling of the normal robots are from the side of the robot. So this is the different type of robot environment which we manufacture. So this will have some liquids can also be taken by a robot in using for vacuum application. Where the channel pots can also be taken by a robot in using for vacuum application. Where I'm not channelite liquids can also be taken by a robot in using for vacuum application. When it is audible, hello, I am corrosive liquids can also be taken by a robot in using for vacuum application. When seeing messages that I'm not video is laggy.
Sometimes your voice is not clear,
Guys,
sir.
am I not audible?
Right now it's
I
okay, sir.
think it is. Right. Okay. I think it's due to the network connectivity. Right, sir. So this is the wet environment robots, and the next will be the steady clean room robots. It is used for ISO class 4 specification, and it is either used in vaccine facility or it is used in pharmaceutical facility. So this ISO class 5, class 4, just a second, ISO class 5, class 4 and class 2 are specifically categorized to the pharmaceutical and medical devices application. In terms of the safety parameters of the customer, we would be suggesting the ISO class based on the application. ESD is for electrical, and HE version is for washing application, and normal harsh environment robots are for industrial and mechanical manufacturing production facility robots. So these are the different type of robot environments which we manufacture, where others doesn't do that. So they already other manufacturers, what they do is that, so in terms of electronic environment, they just paint the robot with ESD paint, and then they will deliver it to the customer in RTS to the ESD version of to the ESD version of robots. So yes, so our robots are generally unique to others. Also, there is some thing called collaborative robots. Just wanted to know, any of you guys heard about collaborative robots, or you guys have any information, or have you seen any collaborative robots or the word cobots? Hello, guys, you can speak up. I think many of you are in, what going through because of the mobile network, the voice and video may be laggy because the amount of data flows. So then it will be difficult. Da Vinci surgical system in a cobot. Okay, so they work with humans. Good others. Yes, right. Right. Okay. Anything else you would want to tell about cobots of what you know about cobots? Oh, I can just wait for 30, 40 seconds. What is a robot? I would request you to go and see what robot is in general. So, how to enter into robotics? I would come to that. Right. So cobots are collaborative robots. So where man and robot collaboration would happen. So in terms of man and robot collaboration, the speed of the robot reduces, but then the safety of the robot increases. So where we have a general chart where it shows. So if you want to achieve speed, so the level of collaboration should be reduced. When there is a amount where an intelligent activity has to be done and it needs a collaborative type of system, yes, collaborative robot is used. So where man and robot collaboration happens, and then the robotic application starts to take place. So collaborative robots are just in simple robots complied with the safety parameter. Yes, complied to a safety parameter where it can work with humans. So when it is working with humans, when the robot path or a movement of the robot affects the human, or when it hits the person, or when it touches the person, the robot will stop. Right. In terms of other robot manufacturers, they have an internal system where they have a resistance from the external motion, then the robot will stop. So assume a robot is doing a manufacturing or a pick and place operation, and the robot hits a human shoulder. So the robot will stop. So, but then anyway, it has to hit the shoulder to understand that there is an obstruction, and then the robot would stop. So in a general collaborative system, you don't need a safety fence. But our robots are different from other robots because it doesn't have to hit the shoulder to understand that there is a person for the robot to stop. So you can see the yellow color robot in the picture, right? So this is just a normal robot, but then which is affixed to touch skin or a air sensitive skin. So this touch sensitivity skin module is attached to a normal robot, and these robots comply to the touch sensitivity. So this touch sensitivity is even more sensitive than your touch sensitive mobile phones. So that level of sensitivity, we are using it for a robotic application. So once it gets in contact with some obstruction, the robot would go into a safety mode where the speed is reduced or the robot would be eventually stopped. So this is the high level of collaboration what we are doing compared to other robot manufacturers. So just a short video on what it is. Yes. So when productivity should increase, the collaborativeness to reduce. When the collaboration increases, the productivity reduces. Yes. Also to increase the safety, so there will be sensors or presence in the manufacturing processes. Yes, once you have a touch skin or a touch arm, the robot will not stop. Yes, and once in this case, the robot can work with the robot. Once the man or any obstruction to the touch sensitivity skin, then the robot would stop. So that is the level of collaboration. Once in collaboration, you can see that the speed would be reduced. Yes, we have 6 type of robots which are compatible with the touch sensitivity skin, and it can be for robots. After cobots, we have a new product called automation and mobility. We generally call it Helmo robot. Right. So to come to a Helmo robot, just wanted to understand what do you know about automated guided vehicle. So if you can comment, you can message, or you can just talk. So what is automated guided vehicle or AGVs? Have you seen any system, or you know about any technology of it? Okay. No. Okay. I think someone said about a sweeping robot or a vacuum robot. How do you think vacuum robot works? In what technology? How do you think a vacuum robot works? In what technology? And you said some guys have seen vacuum robots, right? Right. So, just you had a previous reference, vacuum robot. So, vacuum robot is a smaller automated guided vehicle where it guides itself. So, that is why it is called automated guided vehicle. So, how it guides through advanced software. Okay, so this automated guided vehicle, what you call it, has a LiDAR technology, where this LiDAR systems, which call it as laser sensitive radar systems. So this laser sensitive radar systems is used to detect the obstruction, or which will be used to map the area around it. So assume you say you have docked the robot, I mean the vacuum robot, to a hall, and you have to know where your sofa is, you have to know where your chairs is, it has to know where your dining table is, so as to navigate the robot itself to do the vacuum operation, right? So how does it do that? So it has a software where it has a mapping technology through the LiDAR sensors. So this is the same thing what we are using here. So the technology had gone from industrial applications to home applications. So that is what the difference is. Yes, so this is a automated guided vehicle. Uh, so where it has LiDAR technologies, so you can see all the sensors on the sides. So where it can sense the obstructions or the equipments or whatever systems outside. So it will map the system, and it will navigate to the required destination and path. Assume you have product A in room 1, and you want to move the product A to room 2. How would you move? Easily man can pick and then move. What if it is something heavy or you need automation system? What robot does is that you can, if you integrate that mission or the product with the robot automatically goes to the system, it picks the system, and then it is placed into room 2, right? So in this case, the AGV is mounted to a industrial robot, right? So in this case, you will have the higher productivity. Assume, I think, as you guys are mechanical, you would know what machine tending application is it, right? CNC blanks machine tending application, right? So you have a raw blank, right? You have 5 CNC machines running in series, right? What the person has to do, he has to pick a raw blank, load the blank into first machine. After the first machine operation, he has to put the new blank to the first machine, and old blank from mission 1 to mission 2. So then it has to be seriously it has to be automated in a series, right? So then how come a man can be efficient and can understand and then do that automatically? Anyway, the man can work for a few hours and then he need a break, but then the robot cannot. Our robot doesn't need a break. So where this robot understands the five systems, and all the five CNC machines are connected to the robot, and then the robot intelligently understands the raw blank. It loads to the first mission, and the old product, I mean the already processed product from the machine 1 is loaded to mission 2, and the already processed mission 2 product is loaded to the mission 3. So in this case, this Helmo robot will work, where the automated guided vehicle will guide the physical robot to move and then access other missions. So you can just ask me a just question where, okay, so vacuum robots are also automated guided vehicle. It is so smaller. How come this robot is very big? So what is the difference? Okay, I would tell you. Vacuum robots are smaller because the battery capacity of the vacuum robot is smaller. The maximum your vacuum robot can do is 45 minutes of job, where if your house is more than 800, 900 square feet, it will take more than 45 minutes of vacuuming to be done. So in that case, the robot has to recharge itself and then do the second process. So as because it's only having 45 minutes of operation, the battery is small and the operation, the build is also small. In this case, the automated guided vehicles are bigger because it has to power a bigger robot. See, anyway, the robot has to be connected to a wall socket. The controller has to connected to a wall socket, and the robot has to connect to the controller, and each one and also to the controller. Where in case the robot is mobile, so there is no wall socket or nothing, but you will have a inbuilt battery system inside this AGV. So that bulky battery makes the AGV bulkier to move it. Anyway, when the robot is doing a high speed application, it needs peak current, right? So once you need a peak current, you need a running an efficient battery to draw the peak current and do the application, right? So that is where, so we provided a able battery and a high capacity battery in the AGV. So that's why, because of the battery, the AGV is bulkier. But then if you come to have the other systems in terms of lidar systems, sensors, and other navigation systems, it is just smaller. So just because of the battery, it is bulkier. So these type of applications can be used in mission tending, where it can handle 10-15 missions at once. Okay, and also it can be used for heavy payload applications also. And we have been working on a system where there is a warehouse. Once you have ordered something, the robot will automatically assume person A has ordered a watch, a phone, and something else, right? So and a home product. So then the robot, once the data gets to the robot will understand, okay, product 1 is a mobile, then product 2 is something else, and product 3 something else. It will again pick that and it will put it in a cart, and it will take it to the operator, or it will take it to the other robot. What the other robot or the operator can do, it picks this 3 products. It goes for packaging, and it goes for stickering, where your address and everything is pasted, and it goes for sorting, where it is going to outside facility, where if it is a Bangalore facility, if someone ordered from Mumbai, so then the sorting happens in terms of location where the shipping needs to happen. Yes, so these type of applications also can be done by this mobile robot. So this is a different type of application. So yes, this is a small video on what you can do with Helmo robots. Yes, this is the laser mapping technology which is being done. So it will map the whole system, and then the software will know what is there in place. Assuming there is a machine which is being moved from one position to other, so then the movement of machine also will be understood by the robot, and it will be mapped. And the recent mapping will be taken into consideration for navigation movement. Yes, it has a Wi-Fi access, and it will be connected remotely. If you want to send sensor feedbacks, it will be through a normal wire feedback or Ethernet or Profinet Profibus facility, right? So if it is a mobile robot, how communication would happen? It would be through Wi-Fi and Bluetooth. Yes, once the charge is reduced, so there is a socket connector, so where it connects to the wall socket, and then it charges itself. Yes, this is the work envelope of the robot. Yes. So it can work 360 degrees. Yes, the robot tool can be changed based on the different variants of components which has to be handled. Yes, we can mount different type of robots on HGV, either TX90, TX290, or TX6040 or 90XL. Yes, our AGVs can handle all our variants of robots. I think if the video is not clear, it should be the problem with the network connectivity. And pardon me for that. What is L and XL means? Yes, XL and L means in terms of our terminology, it is the extended length. The payload and the robot capability will be the same. L will be extended to around 200, 300 mm, and XL will be extended. The reach of the robot will be extended to around 500, 600 mm. So that is why we call it TX290, TX290L, TX290XL. So this is the extended reach of the robot. So, but then only the reach of the robot will be changing. But other than that, everything would be same. So that is what it is. Yes. So our robots are ready for Industry 4.0, where it can use for smart connect, smart communication, where it can communicate with warehouse management system, where mobility and tracking and production and collaborativeness will also be integrated to this Industry 4.0 system. Yes, our robots are Industry 4.0 ready. So in terms of what robotics are, flexible programming where the arm is connected to the controller, and the controller can be accessible through a remote software, and the dependent is connected to the controller. So the controller will have all three products, which is variable assembly language products. So variable assembly language is the type of programming system or the programming software what we use for our robots. Yes. So Stobly Robot Suite is a system which includes all three products also. So in general terms, the robot will be sold with the controller and the teach pendant. The controller will already have a software, but the controller will not have a Stobly Robot Suite, because you can in the controller you can only program, but you cannot do any simulation because the robot is connected to. I mean, the teach pendant is connected to the robot. So now in terms of Stobly Robot Suite, this is the offline programming system where this software enables you to import the 3D file. See, assume there is a pick and place application. In design software, you have designed the system in such way that the robot, the machine, everything is present. You import the 3D file to our Stobly Robot Suite, and then you place our robot to the 3D design where the machines are. So then you will understand the reachability, the payload, the cycle time, the throughput, the capacity, the high speed process and applications, and you will know what would be the cycle time as well. So this is what we call as Stobly robot suite, where you can import systems and you can program and you can check the feasibility on how the robot can be done. Also, this robot can be mounted on a floor, can be mounted on a wall, or it can be ceiling mounted. So it can be three type of mounting, and also two three products of us are 360-degree mounting. You can mount it any which way. You can mount it 45-degree, 30-degree, whatever it is, based on the customer application or whatever application it is. Yes, all our robots are connected to CS9 controller, and then to teach pendant, and we have all three languages which I have mentioned. Stobly Robot Suite is a PC suite where you can import, connect, develop all the simulation tools, and Optimize Lab is a separate software in the SRS where you can use to optimize cycles, and Maintenance Studio is also there. So everything is what we call inducted into Stobly Robot Suite. You can design, you can install, you can produce, and you can maintain. So it is a whole cycle of robotic operation where we generally call it as a Stobly robot suite. Stobly services, yes, we are there for engineering, after sales, pre-sales, service, support. So we are there 24 hours for our customers. So yes, so thank you for your attention. What I have done is to generally help you understand what our products are. So what robots are generally are, what we are doing, where we stand in terms of robot capabilities, and what we are compared to other robots. So I have given you a basic understanding what our robots are. So what application can be done. So what is the use of our robots, and what we can do is I can take questions now. So you can message me or you can talk to me for any questions. So after the questions, we'll have a 10 minutes break. And after the break, my colleague, Mr. Mohan Trivedi, will join, and he will be telling you in detail or basic understanding of what SRS software is. So what are its functions, what are its UI, and how we are going to, how you can learn and understand the software. So so anyone has any questions, you can either raise hand. I think I would stop my, yes, I would stop sharing. Yeah. How can robot recognize things? Yes, a robot recognize things based on the feedback from the sensor. So assume you have a pick and place of a system or CNC application. The CNC machine has to be integrated to the robot. It has to ping the robot to say the component operation is finished. I mean the machining operation has finished in the CNC. Then again, once the machining handshakes feedback happens, then the door opens. Then the door opening sensor feedback is also communicated to the robot. Once the robot gets the feedback of door opening of the CNC machine, then the robot will go inside it. So then there is a lot of handshake signals of the machine and the robot to understand the robot, to see what operation it needs to do based on the programming also. Yes, programming is 100% compulsory in doing robots. Without programming, so how will you tell the robot to do some operation, right? So it is not an artificial intelligent robot yet. Now, how are sensors made? I think you need to Google that. Sensor is a device which can sense the presence or absence of it. It's just 1 and 0 feedback, I think, if you would know. What type of AI using, whether it's programming or some other, prologue or some other. I think, see, in terms of AI, artificial intelligence, it is still in initial stage. I would tell you an example of what artificial intelligence can work in a production system. Assume there is a engine manufacturing facility, or you okay, let you can take it as a car manufacturing facility. In a car manufacturing facility, you will have chassis manufacturing, painting, you will have engine assembly, you will have electronics assembly, you will have a lot of applications, and you will have thousands of robots in that. So in terms of artificial intelligence, I would know. So assume there is robo A and robo B. So both are doing separate operations. These robots will not speak to each other. So there are systems where these robots can speak to each other and get each other's data. So once the robo A knows that the robo B is doing work efficiently. The robo A will able to replicate robo B's activity to make itself also be more productive. So these type of system is possible based on warehouse management system. Once you connect all the robots to a single software and connect and you make it interact to itself, then it will automatically able to understand the data and proceed further. So even this has to be programmed. Can robots be hacked? The robots cannot be hacked unless and until it is through an internet. I think you will be connecting to internet very rarely because you will be connecting the robots to your machines where you are doing all the manufacturing. Anyway, if you're doing any application, the robot will be connected to a PLC. Uh, so the PLC will be able to give command to the robot or give the sensor feedback or give the handshake signal. So whatever it is, the robot, I would say, no one will benefit in hacking a robot. Can we control the robot if it is facing some trouble and not doing respective work? Okay, I understand. Sometimes the robot might go into error, so you will have a warning signal or a tower lamp. Okay, so the safety parameters is different for different companies or customers who they require robots. So some people will see error logs in their HMI. Some people will have a tower lamp where some error logs come up. So then the red light will be emitted on from the tower lamp. So these type of different systems can be integrated for the safety. So once there is any indication that the robot is wrong, then the operator can go change, see what the error log is, and based on the error log, it can they can modify and edit the program and make it work better. Which branch engineer to manufacture robots? So see, in terms of robotics, mechanical engineers are required, electrical engineers are required, programmers are required. So that is why in terms of mechatronics, many people go and seek robotic jobs actually, robotic careers. Share my experience with robots. See, initially I have experience in terms of programming of different robots. I was taking care of full all-round design, technical sales, programming. So I was into different systems, and now I'm into business development or industrial robots. Yes, so my experience of robotics is into many means actually. Which country first invented robots? Yes, Unimation was the first company to invent robots. It's a US company. It has been acquired by Stobly. It has been acquired by us. Yes, could be the United States. And after the World War, you can see many scientists migrated from Europe. And I wouldn't say there are scientists who have this much technology or who have produced this much technology, has invented this much technology, are natively from the US. Yes, everyone had migrated to the US. Anything else? Share my journey. Share my journey. See, I'm a basic mechanical engineer, right? And also, I was intrigued into industrial robots, and I got an ample opportunity to go into this field. So, initially, I had to do all the work in terms of programming, design, sales, also technical support. So, other than service, I had to do all the work I have done. Then I have projected my career into business development into industrial robots. Yes. So, the main qualifications to enter into robotics, you just have to you can have a degree in either electrical electronics or into computer science. But then if you are into computer science, your career in robotics would be for programming. If you are into electrical and electronics, you can be into PLC and other integration of the robots. And if you are into mechanical, you can do design and business development and others. Just give me a second.
So students are requested. Okay. So another speaker will join within 5 to. Again, he can. Again, he can.
Yes, yes, sir. What we can do is, if the students want any questions, I can take any questions, and we can have somewhere around 10 to 15 minutes break based on your comfortability. Then after the break, my colleague will be joining. So yes, sir. Anything, guys? Any questions? Anything? The robots you explained is limited to their work. So the robots are limited to their work. No, the robots are not limited to their work. The robots is limited to the program what you feed into it. So it's based on your crafting ability of programming to do various applications. How did I enter into robotics field? Yes, it's my interest here. What if controller is hacked? So I think a controller cannot be hacked because to change some safety parameters you need user id and password. So it will ask you unless and until you key in that user code and password, so you cannot do it cannot be hacked. You cannot change the safety parameters without the password. Yes, so it is safe. Okay, so robotics are increasing work or decreasing jobs to humans. Okay, let me tell you. So you have a productivity of a manufacturing line, and you can understand the manufacturing takes place in 3 shifts based on the customer requirements and the order requirements. A man cannot work 3 shifts, right? And also a man cannot do high accuracy jobs. So in terms of painting application, as you see in industry, painting will emit lots of chemicals, and inhalation of humans of the paint will be a hazardous to their nature. Do you think the human is happy doing the painting job of the robot? No. So painting job, no. The humans are not happy doing the painting job. Also, the accuracy, the amount of paint which is sprayed. So human doesn't know how much time. If even if the human delays painting for 1 2 seconds, the amount of paint sprayed, then there will be an overcoat of the paint. So there are few applications where robots are necessary ultimately, and no one's job is taken. So instead, we are hiring more robotic engineers to help us program, service the robot, and also design the robot systems. I mean to say, we are in general we are giving more work to skilled workers than unskilled workers. Robots having thinking capabilities are far stretched here. I don't think it will be having that system. So any manufacturers will not be going for it. So we want to program the robot based on what we want. We don't want the robot to think itself and do some things by itself. It wanna, my company is not working on humanoid robots. Yes, we are not working on it. So we are doing the valuable R&D to increase the capacity of the products or the capability of our products, not to R&D. There are other companies who do that, but I don't think it will come into existence. Assume you think there is a humanoid robot, there is some Boston Dynamics company, as you say, robot dogs, or those are done by Boston Dynamics. Do you think they will make the robots commercially viable? As of now, I don't think so. You would need a proper application to make that commercially viable. I don't think they would be for commercial. Yes, the robots can work underwater. Yes, our robots are IP67 and rated. So yes, our robots can do that. Do you think we'll have a universal robot to suit all needs at time any soon? There cannot be one robot which can do all the process, because each and every application is different. Assume you want to handle small application, you cannot give a bigger robot, right? So you need separate robot which can handle smaller applications. So there cannot be one common robot which can do all. So you'll need different applications and different robot. I mean different robots to do different applications. Sensors are active in water. Yes, the sensors which are active in water, see, the sensors are inside the robot, right? So if the robot goes under the water, then the water would not enter the robot and the sensors are not affected. So I don't think it would be of any problem of sensors active in water. What is the average price of the robot? I don't think that would be necessary here. Can robots be used for farming? Yes, you can go Google, or I mean, you can go YouTube this robots in farming, where the artificial intelligence software. I will tell you, there is a tomato cultivation facility. I mean, not in a land, so it is in a facility, right? It's in a plant, in a facility they where they culture organic tomatoes. Okay, so to understand which tomatoes is ripe and which tomatoes are not ripe, so the robot has to pick the ripened tomatoes, right? So to pick the ripened tomatoes, it can recognize the tomato by its color. So the ripened tomato is red, unripe tomato is green. So in identification of red tomato to the green tomato, artificial intelligence software is used to pick it. Yes, you can Google that. I mean, you can YouTube that, and you can check robo picking tomatoes, robo picking apples, or robots in farming. Yes, you can do that. Yes, robo can work in furnaces. So there are different things actually. So if it is going more than 600, 700 degrees, the robo cannot go inside the furnace, right? So that is not at all possible because the electronics will get fried. So if you're loading the component to the furnace, after curing, the component comes out of the furnace and the robot tests it. Loading and unloading to the furnace operation is possible, but then robot cannot go in the furnace. No robot can go inside the furnace. Which materials are used for robots working in water? Okay, so the robot will be having 6 arms, right? As I said, six axis arms. So all the robot arms will be pressurized, where the seals are so strong that the robot, I mean, the water doesn't enter the robot. So that's it. The arms are pressurized. So there is some separate safety parameters for ingress protection. So we follow all the safety parameters, and then it can work underwater. No, yeah, there is no robot like Chitty. Robots cannot be misused. See, industrial robots cannot be misused because it is only you can program it, and you can make an application, or you can move the robot. In terms of artificial intelligence, then it can be misused. Yes. Yes, robot cannot turn into prosthesis for humans, but robot can do prosthesis for humans. I'll tell you. So if there is a spine implant or a knee implant or any prosthesis, in terms of polishing, deburring, yes, our robots can do. It cannot change into that prosthesis, and it can do. Yes. Yes, the robot needs regular service and maintenance, 100% as everything do. So every once in a while, humans only get tested to doctor for general medical things. Actually, even get we get general testing every year. But then why not robots? Yes, robot needs testing. Robot needs maintenance. So there is predictive, preventive, maintenance. So things which we can predict, we will predict and suggest. The things which we can prevent and we have experienced previously, we will suggest that customer. There are a few unattended maintenance, I mean, where you unexpected maintenance that you have to work on the spot. Okay guys, what I can do is I can give you 10 to 15 minutes break. You can come back around 11:30 and we can continue. I hope I'm not boring. So that's why I wanted it to be an interactive session. Dean sir.
Tell me, sir. Thank
Sir.
you very much,
Sir, we
sir.
can have 10 to 15 minutes break. Students can have their time, and then we will come back and my colleague will start.
Just 5 minutes. No, sir. So your colleague has come just now. He has reached.
Yeah, okay.
So he will join
Right,
within
sir.
2 to 3 minutes, sir.
Definitely, sir. You can check with the students how much break they want. Maybe 5-10 minutes you can give them.
Okay, sir. No break, sir. For no students, no break. It's okay, sir. Thank you very much, sir, for giving
Okay.
a lot of information about tablet robotics.
Sure, sir. Thank you, sir. So it is my opportunity and honor to educate the students, because when I was a student, no one educated me on this. So thank you, sir. Thank you for this opportunity.
Yes, yes, because this is a good subject, sir. So as a researcher, so my area of research is optimization. So one of my friend is working in bipod robotics, sir. So I know I have a little bit about this robotics, and this is the hot topic in research in these days, sir. So I think it's very useful to students, sir. to choose the means
Definitely,
their career.
definitely, sir.
Yes, yes.
Definitely, sir. Yes. So that is why we are here. So maybe at the end, maybe we can tell you what the career of robots can
Yes,
do. Maybe we'll take few minutes to help you understand what the robot's career would be at the last
yes.
once we finish it.
I think from
And also, we are overwhelmed, sir. See,
sorry,
because
sir.
I'm overwhelmed because there are more than 270 participants actually. So I could understand that students career, they are taking it more seriously and they want to learn more things. So it's
Yes,
not just the education what they do, they want to learn more new things. So I'm just happy that I can see more people joining in. Seriously, yeah.
yes, sir. Yes, sir. Thank you, sir. And somewhere in the YouTube also, sir. So we are giving a YouTube live also, sir.
Oh, is it okay? All right,
Uh,
sir.
so in that web, in that online somewhere are there, sir.
Oh, okay, sir. All right,
Okay.
sir.
Thank you very much, sir. Thank you very much.
Thank you, sir. Thank you, sir.
Okay, sir.
Guys, you can take a short 2 minutes or break or something. You can do some of your work and then come back. Yes.
Yes, sir. Yes, sir. Okay, sir. Sure,
So
sir.
my colleague will be joining shortly.
Yes, sir. Yes, sir. Okay, sir.
Thank you, guys. Thank you. Thank you, guys.
Thank you. Thank you very much, sir, to join with
Anyway, I will
us.
be sure, sure, sir. Thank you. Anyway, I will be there with you guys till the session ends. So if there is any doubts,
If
either
time
me or my
permits, sir,
colleague.
we will call you physically to give some demonstration on robotics or something. Sure. So we have
Definitely, sir.
some tech fest or is there also there. So
Sure, sir. Definitely.
after this pandemic situation, so we will call you physically, sir. We will talk, sir.
Sure, sir. Sure. All right, sir. I think
Okay, sir.
from my background, you can see some robots in our facility, I believe. So these are the two robots.
Yes, sure, sure.
Yeah, I'm showing. So these are the two robots. So this is a six-axis and this is a Skara robot, right? And this is the TP80 robot. So this is also in our lab, and this is the other robot, right? So yes,
Show them TP80, TP80.
uh, TP80, right? This would be the TP80. This would be the TP80 robot.
My mic is unmuted, sir, or I have to unmute it? It's still. You joined first, sir. Sorry. You joined. Yeah, I think. Trivedi, Trivedi. It's not showing, sir. Just trying to show you. Join all this. Join all this. No, Trivedi, yes. Trivedi. No, no, just I wrote Trivedi. That's good. Yeah, yes. Was divided. Also present in the. Before you start the session, introduce yourself. Sure, sir. Dear students, so another our speaker is going to join to give more information about that Shabla robotics.
Humanoid robot. Yeah, it's all into preliminary stage. If you want to learn humanoid robots, you have to go for artificial intelligence systems or machine learning, so that that software can learn the environment. So it can know what is the environment out there, and it can reciprocate the system. So it needs highly enhanced software and R&D for that. Technical error. See, if there is a technical error in the robot, we can reboot the robot and check the error, or we can download the error logs and see where the robot has gone wrong, either physically or it is a sensor problem or it is software issue. So we can check that in error logs and we can do that. What is the skills? So if you want to proceed into robotics career, the skills, you can have good skills in design, you can have good skills in programming. So you can have good skills in electronics and PLC communication sensors. So that would be good. Sophie robot, it is just an artificial intelligence robot. Yeah, it is just like an Alexa, I would say. So Alexa, based on your speech, so it will recognize your input and then it gives the output based on your speech. So it is the same. So it is nothing big Alexa actually. Can robots be recycled? Yes, it can. Not the full robot cannot be recycled. So basically, we try to manufacture robots with the parts which it can be recycled.
Yeah, Tejas, good morning, Tejas.
Thank you, guys. Thank you. Good
Tejas,
morning, Mohan. Good morning.
Yes, how are things going on now?
Good. Good, yeah, good. So, how is your visit to NIT? I think you are with Dean sir right now.
Yes. I am with Viresh Kumar sir now. Obviously, yes, it was a warm welcome. No problem. And how far you
Good,
have
good,
completed with your introduction and all, right?
Yes, I have completed my
See.
introduction. I just given them basic knowledge on robots.
Okay.
So you can start with your Stobly robot suit software directly.
Okay.
And then you can tell them about the software. Yes.
Yes.
And I'm just
Yeah, please.
happy in this demo because the students are more interactive. So if they are not talking, at least they are messaging in chat. So I'm loving this session.
Okay, I see a lot of questions where is popping up in chat window. Oh my God, a lot of questions. Yes.
Exactly.
Let me check. And will
People
you
are
be
very
with me or do you have
interactive.
any other assignments now?
Not an issue.
Will you be with me at the end, till end, or do you have any assignments?
Yeah. No. I will be there in the
That's great.
meeting.
Okay,
Yeah,
fine.
no problem. Yeah, sure.
Okay,
I'll
that's
mute
great.
myself
Okay,
and I'll
thanks.
stop my video so you can do that.
No, yeah, if you also not stop the video, then I could not see any face. No, don't stop your video. No problem. Let it run. I cannot see anyone here.
All right.
Okay.
You're already seeing me every day in
Guys,
office.
if you have any videos, you can. What?
You're seeing my face in the office. Why do you want to see no one? All right. Okay. I can.
Okay. Anyway, guys, if you have any video capabilities, you please switch on. And my session will be an interactive session. I won't keep on saying like my colleague said. This will be an interactive session. You have to answer my questions. Please, guys, if you have any video compatibilities, please switch on your videos so that I will give you just 2 minutes. Lag happened. Okay. Oh, only my colleague is very interested. Oh, okay. Anyone else? There will be a lag if all bandwidth lag will happen. Oh, okay. Fine. Okay, anyway, no problem. Let me introduce myself quickly. After that, we will jump into the session very fast. So one thing is, if you face any problem with my flow and all, no, just let me know so that I can slow down, or else we can go a bit fast. Okay. So myself, Mohan Trivedi, and Veeramal Mohan Trivedi, and my education qualification is MTech in Mechatronics and MSc in Human Psychology, and specialization in electrical in BTech and Mechatronics in MTech. And universities from JNTU Hyderabad, the Central Institute of Tool Design. Currently, I'm employed with Stobly Robotics. Previously, I'm employed with ABB Robotics, and designation is in application engineer. So I have around total years of around 8 years of experience in industry, only in industry. And work industries like I have very experienced on diverse industries like automobile, robotics, and low cost automation. So let us quickly jump into agenda now. So today in this session, we are going to learn about basic robotic systems and oh shit. Yeah, because it is very, yes, okay. Okay. Okay, so let us quickly jump into our agenda now. The thing is basic robotic systems we are going to learn about, and basics of servo systems and basics of pneumatic systems, introduction to simulation softwares, SRS as a game changer in learning aspect, and introduction of Val 3 programming, and which year, first year? Okay, so now basic robotic system consists of a manipulator, legged robots, wheeled robots, and UAVs. These are the types of robots generally we will see in any industries. Basically, generally we will see any industries. So a robot is a programmable, multifunctional manipulator designed to move material parts, tools, or specialized device through variable programming motions for performance of various tasks. So actually, this is a definition of robotics basically. And we have different types of robots. One is manipulator robots, next is legged robots and wheeled robots and UAVs. And especially we will deal with, Stably is dealing with only the manipulator robots, not legged robots, not wheeled robots and UAVs. Okay, basic robotic system manipulator consists of 6 joints or 4 joints. And these are very successful in repetitive jobs and very tedious jobs, basically. Okay. Okay, now comes the interesting part. Sorry. When office is in. Live lo ఇది వస్తుంది. Okay, fine. Okay. Okay, please open your chat windows or else you can talk to me now. It is an interactive session now. Now, I want to ask you a question. Everyone is ready? Okay. See, can you see your screens now? Let us come to problem number 1. Problem number one. So I have to move. This is block A. This is block A. I have to move this block A to 500 mm. So how do you solve this problem? So first rule 1, we have some rules here. Rule 1, don't jump into any conclusions. Rule 2, I don't want any hi-fi, hi-fi gadgets carrying on here. Rule 2. Rule 3, be open to talk. No problem, whatever you say. Okay, so I just want to solve this problem by you. There is a block, weight is around 1 kg. You have to move this block from point A. This is point A. Where is this? Okay, this is point A. And from this point A, you have to move this to point B. How do you solve this? I can see the chats popping up, but I cannot see it. Okay.
Who is
By
this here?
pushing-
By pushing the block.
Yeah, it's okay. It's okay. No problem. Sit and place it.
Pick it up and place.
Fine. Okay. Push towards block B. Push towards. Okay. Push. Can you repeat it? Okay. Who is it? Suraj. See, basically the thing is, I want to move this block, this blue block, to 500 mm towards my right direction. It is in left direction. I have to move this block towards right direction. How do you do it? Help of robots. Okay. Pick it up, Stably robot, and keep it. Oh, please don't what do you say that? Talk about Stably now. I am not a Stably guy now. I am just a layman. Please don't take Stably name here, please. Just kick it. Very good. How many parts you will kick? Okay, tumble it 50 mm very short distance. 500 mm is very short distance. Okay. Conveyor belts moving through 500 mm right side by arranging block. See, I need a solid answer of automation. Solid
Yeah, in
answer of
terms of
automation.
programming logic, you can tell.
Yes, I need a solid answer of automations. Like, please don't kick, please don't push, because I am a owner of a company. I cannot afford a guy over there. By applying force, how do you apply force? Who is that? Oh, it is scrolling very fast here. Applying wheels and programming. Okay. Condition to move. Command. Okay. Command to move. To which command you will give? Sai, right? Saket. Sai Saket. How do you command and what do you command to move? Create frictionless surface. Okay. It should be a controlled process. It should not be an uncontrolled process. Any answers? Programming of robot? No. Please don't jump into robotics right now. I need a general answers. I don't want any robotics, or that is what I said. Please don't jump into any hi-fi gadgets. Through wheels, magnetism. Oh, who is this magnetism guy here? Wait. Magnetism. Mayank Kumar. Yes, magnetism is good answer, but how do you do it? Conveyor belts is a good answer. Next, how do you do it again? Attachment of magnets to blocks. Okay. Yes. Again, how do you do it? I need only 500 mm to move, not even 1 mm or 2 mm either and there. That means 499.9% also not agreed. How do you solve it? Opposite poles. Okay, we are going to magnetism, jumping into magnetism now. Creating magnetic fields. You have just 1 minute left. You can create your answers, but block need to be magnetized. Electric motor. Yes, electric motor is a good answer. Who is that? Devash. Okay, Devash. Electrical motor is a good answer. Source location to destination location program. Which for what you will program? Sai by Air Force. Okay, Air Force is a good answer, but it should be elaborated. Pulley of 500 mm. Pulley is also good answer. And magnetism, no, you cannot do it. Magnetism. Vibration. Okay, stop. Please stop your answers. Stop flooding your answers. Okay. See, my problem is pullet. What is it, pullet? Sai Bhargav, no? Sai Bhargav. Okay. So my problem is to move a block from point A to point B. So for that, lot of answers I have expected. Spring mechanism, no. Spring mechanism, you cannot achieve accuracy. What is, you cannot achieve the accuracy with spring mechanism. No. Sir, first block put in magnetic system, same as block side. No, magnetic also you will not achieve accuracy. What is this? Linder means by wheels. Straight can be used with compress. No. See, basically basic thing is just pushing this block. Yes, first answer is right. By pushing this block for 500 mm, you can achieve this one thing. By automation, we have to achieve. In automation, we have different ways to achieve this. By pneumatics, by hydraulics, by motors, and last is robotics. The high-end version is robotics. So how we will move this block from one part to another part by air. Pneumatics is just air. Somebody have given me the answer like air, right? So that is called pneumatics. How do you get it? How do you do it? That is a different concept again. But by using air, you can do it. That is first thing. And by using mechanical motors and by using mechanical pulleys, yes, we can do it. And motors controlled by controllers by bullet. Not pneumatic, pneumatics, by pneumatics, creating pressure. Yes, exactly. By creating pressure to some cylinders, you have to move these blocks from one point to another point. The same pressure, if it is air, that is pneumatics. If it is with fluids, that is hydraulics. And the last comes with thing is robotics. Get it? Any doubts? Yes, pressure difference. Oh yes, obviously we'll have a pressure difference. Applying pressure is easy. How? Applying pressure is not easy, boss, because we have a separate. We will have a separate system for that. That is a very big system. I will show you now. Who is the Shivaji? G Shivaji. Yes, that's a very big system. We have to maintain a very big system. I will show you now. Okay, everybody is clear with this part? I just want to say yes here. Anything else you want to know? Yes. Only one S? Yes, yes, yes. Yes, yes. Okay. So now coming to problem number, so something is came, Bernoulli's theorem. What is this? Pramod Kumar, what is Bernoulli's theorem dealing with this? Okay, anyway, now creating frictionless surface. No, that is uncontrollable process. We need a control process. We need a control process. Pressure difference, okay, using hydraulic system. Okay, Prem Kumar, you know about hydraulic systems, right? Anyway, that is good. That is good. Water gun, no, water gun cannot be. No, that is also uncontrollable process. Remote controls, what you will control with remote? That should be specified. Okay, anyway, stop flooding answers. Your time is up. Stop flooding answers. Eddy current creator, stop at the distance. What is this? Destination. You are going to the concept of what do you say that gravitational, this one, right? We will have in amusement parks. That concept you are going in. Yes, that is also can be done, but it's a little bit complicated. Pulley system, yes, pulley system is mechanical system. Yes, you are right. Okay, stop letting answers. Thank you very much. Thank you very much. Now, yes. Now the thing is, this problem one can be solved with three methods. One is pneumatics, second is hydraulics, third is mechanical system like motors, and fourth and high-end part is robotics. Okay, and coming back to problem number 2. Okay, same problem. The thing is, I have to move this point, I have to move this block from point A to point B. Okay. This block from point A to point B, I have to move it. Okay. Now, I have said my designer that it is not 500 mm. I said it is 500 centimeters by my drawing. But basically, I have to design a system for 500 mm. Rather than that, I have given my designer to 500 centimeters. Now, what will be the consequences? You got my point? Yeah, pneumatics we will discuss. Narla, right? We will discuss about pneumatics in deep. Don't worry. We will discuss about it. So, uncontrollable block B process has to be repeated. What process has to be repeated? See, my question is very simple. This block A should be moved to B 500 mm, but instead of 500 mm, I have given my designer as 500 centimeters. You know the difference between centimeters and mm, no? The system will be uncontrollable if we for such small range. More energy required. I think we are deviating the topic. Please don't talk about energy enough. Pushing is okay, leave it. Pushing, that is a manual interruption. No, I don't want any manual this one. It will travel 10 times that required distance. Yes. Others, yes, 10 times it will required. How do you eradicate that? What is that blue screen? that is a different issue. I'll come back to it. Increase friction of floor. No. See, understand my question. Please understand my question once again. I have to move a block from point A to point B, which is 500, which should be 500 mm. But instead of 500 mm, I have given my designer as centimeters. Instead of mm, I have given as centimeters. Now he will be designing his machine for centimeters. Now what will happen? It will be traveling more distance. Okay. whose distance should be variable. Pressure, additional pressure requires to be reaching point B. Okay. Engine overrun, very good. Distance will increase and will collide with B. Your only answer, reduce the pressure distance. It will cover more cycles. Motor will be required, motors will be required. Okay, all product will be damaged. See, my increase work done the required, conveyor belt is good. Yes, conveyor belt is obviously good. Braking system at B, repeat the process for 10 times. Block move less than 50 centimeters, 500 centimeters, reducing power. We have to repeat the process for 10 times. Okay, okay, okay. Stop flooding your answers. Stop flooding your answers. Exchange the weight. No, stop flooding your answers. So this is the arms fully rather than error occurred production. Yes, yes. Who is this? 1 minute, 1 minute. Please stop your answers. Who is this? Mr. Rajendra. Arm will be lengthier and error will be occurred. Production will be affected. Production will be affected means what do you mean by that? Can you elaborate it? Rajendra. Vishwachandra Rajendra. See, this is the difference. This is the point where we have to concentrate. This is the point where we have to concentrate. What is an academic study and what is industrial? What is industry? Yes, misplaced and wrong position. Yes, yes, yes. This is the gap between an industry and this is a gap between industry and an education sector. So basically, we are thinking about long run energies, everything. We are thinking about loss of energies. And one more thing, what is the production will be stopped, decreased by 10%, repeating process for 10%, reducing power, collision. See, the thing is, what is the problem here is we are thinking everything from the notebook or from the textbook. No, nobody is thinking like, okay, in a generalized way. Everybody is calculating equations, everybody is calculating this one, everybody is writing some equations, energies, everybody. No, I don't want that. I don't want that. This is the difference between, this is the difference or gap. People are talking about education sector gap, industrial sector gap. This is the gap. You understand what I'm trying to say? See, if I give, instead of 500 mm, if I give 500 centimeters, what will happen? My design will go wrong completely. My machine design will go wrong. If my machine design will go wrong, what will happen? Instead of 500 mm, my block will move for 500 centimeters. Is this viable? Yes, you won't achieve your goal. Then why should I design it and why should I manufacture a machine? Forget about your education, forget about your motor losses, frictional losses, this, that, no. But my main goal is not achieved, no? Right? My main goal is achieved or not? No, it is not achieved. Then how to rectify this fault? How do you rectify this fault? See, I have only one thing. I have to move from point A to point B, that is 500 mm. So it is centimeters. We will be recognizing very fast and it is very easy to recognize. But if I design a machine, complex machine like generators or alternators or turbines or something else, if I do this mistake, what will happen? I know it is a silly mistake. Yes, I know it's a silly mistake. Nobody will do that. But let us consider that. What will happen? Increase load. Again, please don't go to textbooks, please. Please don't go to, yes, disaster. Yes, large loss. Exactly. Sell what? Sell it wherever required. Sell it where you will require here. Shivasai Verma, you will buy? Will you buy? Yes, defective product. This construction machine is changing scales. Yes, it's loss. Loss, exactly. Product won't work properly, sort of. You are almost right, but it will work properly, but it will not achieve our goal. Change in quality? No, quality will be same. Quality will be same, but our goal will not be achieved. Quality will be same. No question of production here because we did not move the machine in the floor shop. So no question of production here. Manufacturing will be messed up. Yes. Won't satisfy production is useless. Yes. Result won't be perfect. Yes. Damage occurs. Damage occurs in some cases. Satvik, not in all the cases. Only in some cases. Moving the machine 450 mm. Oh, whoa, whoa, whoa. Somebody. Tiwari. Moving. No. Wait, who is it? Jayant. Move the machine 450 mm. How do you solve that problem here? How that problem will solve? 500 centimeters and 500 mm. Will you move? If you move the machine for 450 mm, that problem will solve? I don't think so. Like in a Bhopal grass tragedy, yes, obviously, but not that much disaster. Only the financial things will be affected. Does it have other uses? Does it have other uses? No, you cannot use for another thing because it's a customized machine. Okay, stop flooding your answers. Stop flooding your answers. No proper final product. Yes, obviously, loss of profit. Okay, obviously. Stop flooding your answers. So now, do you understand what is the problem while designing the machine? Now, do you understand what makes the gap between your education and what is the practical problem? No question of efficiency. Your machine is not even working. No question of efficiency here. So this is the problem in industry we are facing currently. This is the problem. We don't have skilled work manpower who are working, who are ready to work like this. So how to solve this problem? Do you have any suggestions how to solve this problem? To correct the mistakes in designing phase. Boss, please don't again, don't go to your textbooks here, please. Increase the weight, buoyancy laws, Faraday laws, Newton's first laws. No. I'm not interested to listen here. 9 years back, I have learned all these things, please. Changing institute of instruction of the machine. No, it can't help. Please don't go to your textbook knowledge. Please think beyond your textbook knowledge. Only the general thinking is required for me. I don't want your subjective knowledge. No robots. Still, robots are not yet entered. We are in Stone Age now. Changing the program centimeter to mm. How machine design will change if you change the program? Change the machine, other machine. Change the machine with another machine. How do you will change? Another machine to send back to back. See, my question is how to rectify. Yes, how to rectify. But doing repeated work experiments and projects. No. Then my company will shut down for experiments and projects. How do you rectify this 500 mm to 500 centimeters? How do you see this mistake in initial process? How do you see that? You have just 1 minute time, please. I need a perfect answer. Human error. Yes, obviously it's my error. Yes, I was the culprit. You can take me out of the job. No, block should be increased. No. I'm changing. Boss, please come out. Yes. Yeah, they just tell me. Enjoying skilled workers. Against push. Decrease speed. Please come out of your textbook knowledge. Please come out from your textbook. Yes, somebody have said 1 minute. Yes, I got the answer. Pratik, computer simulation. Who is this Pratik? Computer simulations. Yes, that is the correct. That is the right answer. That is the right answer. Yes, we have to go for computer simulations once you design the project. That is the correct answer. Yes, we will talk about that in a short way. Now, for future, we will talk about computer simulations now. How these computer simulations will be affected our machine design and all. Okay. Now, let us come back to our presentation, basic servo systems. So basic servo system, commonly robots will be using the basic servo systems. So different types of motors will be increased. Different types of motors will be incorporated in the robots. One is synchronous motors, steppers motors, AC servo motors, brushless DC motors, and brushed DC servo motors. All these motors will be covered in your curriculum in NIT Andhra. Don't worry about it. So basic servo system, like, see, basic servo systems, like how it will be there is, you will have a command. So we'll have a position control system, PID controllers, that also you will be studying in NIT Andhra, don't worry. So velocity control, that will be controlled by a motor, and that motor will control the load. So encoder will detect the error of the motor and it will control the position. So it will continuously monitor the movements of the motor or else movement of the load. Based on that, we will annotation required. What is it? Okay. So this is the command equipment, and this is a position controller system. So this is torque controller. So these are load basically. Okay, these are load. So whenever we have given a command, this load will act according to this command. Okay, we'll have a feedback control system called encoders. That encoders will provide the error. Based on that error, this position control will control the load. Okay, please don't worry about it. You are first year students, you will be heading for 4 years, you will be studying the same thing for 4 years. Don't worry about it. Okay, so practically the thing is, we'll have a control board here. This control board will control this motor. This is a gearbox for precision, and this is a potentiometer. Basically this potentiometer is there, right? This encoder and this potentiometer is same. And what is potentiometer is, this is a type of encoder. Okay, you will learn more about in your coming curriculum. Okay, just leave it, just listen. Now coming back to shit. Okay, so basic pneumatic systems, like, so this is one of the part of automation where we can do our automation systems, integrated systems, everything will be perfect with low cost. So everything we cannot go for servo systems. Why? Because it is costly. So the lowest way of doing a automation system was LCA, low cost automation. In that low cost automation, this basic pneumatics will be playing a very important role for this automation systems. So this basic pneumatic system consists of air compressors, coolers, separators, receivers, and a cylinders and direction control valves. So these direction control valves are different, that it will control the direction of fluids from actuators. Okay, any doubts? This is a basic pneumatic system which will be implemented in any industry which is dealing with pneumatics. So we'll have a compressed air here. This compressed air will be sent to chillers because compressed air is very hot. After that, it will be stored in a tank. This is a tank. After that, air will be dehumidified. After that, it will be sent to system. This is called a system. This is called a system. Yes, air brakes, everything. Okay, we are coming to the main part of the presentation now. So how simulation software will help to understand what we have done is, we have just seen an example before slides, right? So if you do any mistake in your notations, instead of centimeters or mm to centimeters or inches, if you do any small mistake, that will be drastically affected. You know, in France, instead of inches, they have given due to some conversion issues. Total rail track have been again they have constructed. I think it was seen in Facebook. How many of you seen this? In France or some other country, I am not sure about it. So this is the importance of simulation. The importance of simulation before raise hand. Okay, Venkat Reddy, sign it. So this is the importance of simulation now. Okay, so we are learning important aspects of simulation. First thing is robotic simulation used to create an application for a physical robot without depending on actual machines. So we will not depend on actual machines, but only by the simulation software purpose. Simulation itself will understand how that machine is behaving in a practical way. This will save our cost, time. In some cases, application can be transferred from one other The same application can be transferred from one project to another project to rebuild, to replicate the machines. You understand? So this process will help us to understand how machine is behaving in the production floor, not physically, by through the simulations. 90% of the results will be accurate by the simulations. So that's why whatever we do, whatever we design, we will go for simulations like CAD. Okay, CAD is a designing software, sorry, CATIA. Okay, and some other softwares like CATIA, ProE, ANSYS. So these are the software for only for simulation purposes. But basically the thing is coming back to our robotics, how the simulation software will work. That is very important. So you design a machine, MATLAB? No, MATLAB is not a simulation software. It is just an analytics software. Yes, we can do simulations also, but it is like what do you say that physical layers of the machines cannot be done with MATLAB. You can go for mathematical analysis and mathematical analytical this one with MATLAB, but not with physical layers and all. Okay, so simulation softwares are very important for doing some R&D things also, and for designing machines also. Way forward. Okay, list of simulation softwares, right? For used in robotics was SRS. We have that's the first thing, and RoboDKs, Robot Studio, RoboCAD, and RobotSim. So basically today we are working with SRS. Why? Because RoboDK is with another company and the Robot Studio is for ABB. RoboCAD is an open source software and RobotSim is also open source software, but it required the license. You cannot use it for open source. Okay. Okay, Stobly robotics suite. I think my colleague have explained everything about Stobly robotics, right? Yes or no? Okay, how do you like the robotic colors? Color is good. Okay, fine. So let me quickly refresh what my colleague have said. Let me quickly refresh so that we will be way forward. So this is called CS9 controller. This is called CS9 controller, and this is called TX2 arm. This is 6-axis arm. Okay, we have two types of arms. One is for 6-axis, one is for 4-axis. 4-axis also called as SCARA, SCERA. I think this was said by my colleague, right? So 4-axis is called SCARA and 6-axis robot. So this is called CS9 controller. This is advanced controller where we have started recently working on it from last 1 year or 1.5 years. This is our CS8C controller. This is just 5 to 6 years back controller. This is. So this series starts from TX and this series starts from TX2. Okay. This is the general classification of our robotic arms. One is CS8C controller and one is CS9 controller. Okay. Now, introduction to SRS. Why we have to use SRS software? Why we have to go for simulation? What is the need? So basically the thing is these softwares are very powerful tools to analyze, to apply and to decide. So basically anything what we will have 5 stages. Okay. First stage is conceptualization. That means you have to conceptualize what you are trying to do. Suppose I want to move block A to block B. How to do it? By pneumatic systems or by electrical system or by hydraulic system or by robotic system. You have to think, you have to brainstorm and you have to come to a conclusion. What type of system I have to use there? It should be efficient and it should be economical. Okay. So that is the system you have to adopt. So first thing is concept. Next is simulation stage. How my concept is working practically. You cannot always manufacture a machine to understand how your concept is working. That is waste of money, waste of time. Nobody will allow you also. Nobody will allow for that also. Okay. So you will go for a simulation. That means that you will understand practically how my system is working on and how it is behaving on the production floor. Next is setup. What is meant by setup? Stage 3. You will construct a machine. You will construct a machine. You will integrate a machine with robots, or you will integrate a machine with. You will integrate something. Yes, building and simulation. Not simulation. Simulation will not come here again. Only the building, the cylinders, everything. You will build accordingly. You will write accordingly. That means you will design. You will construct accordingly. How machines? Did you see any machines? Let us suppose you are working with a mixer. You are working with a grinder in your kitchen. So how it is directly? It will not be directly from shop. It is directly coming to your home, right? No. Behind it, we have lot of process to do that. Lot of process to do that. Lot of process. You have to assemble the system. You have to bring the parts. You have to assemble the parts. You have to test it. So everything will be coming into the setup stage. Okay. After setup stage, we will go for production. Let us suppose you are manufacturing grinders. Okay. Not grinders, or else mixies. So you will produce mass mixies for one shift, 200, 300, 400. You will produce. How many of you know Bangalore Honda plant? Anybody know Bangalore Honda plant? Anybody is working? Your cousins, sisters, brothers. In 1.2 second, production is in large scale. Yes, in 1.2 second, you will get one bike. you know, one scooter, not bike, I would say, scooter. In 1.2 seconds, every 1.2 seconds, you will get a bike. Silicon Valley of India. What is it? Bangalore? Yeah, maybe. Yes. I'm not talking about Silicon Valley's boss. So if you produce, if you design a software, if you set up, so result should be like this: 1.2 bikes per second. How many of you know Tata plant in Pune? Tata plant, Tata. Anybody is working? Your parents or your brothers, sisters. How many of you? Anybody know Tata plant Pune, Pimpri Chinchwad? Yes. Did you ask them what is the production for one day, Ayush? Did you ask? Anyone interested? Anyone interested to know what is the production rate of the Tata Motors? Yes. What is the production rate? 730 per, what is it? 730 per day. 730 per day. Which model you are talking about? 730 per day. Yes, almost 800 per day basically. Almost 800 cars of Tata cars will be Tata Indica. Tata Indica cars was production was stopped here. Long back Indica was stopped. 1,000 cars per day? No, not 1,000. 800 cars. 800 Nexon cars will be coming out of Tata factory every day in 3 shifts. Yes, Nexon. Yes. What is the production of Jaguar? Jaguar. Mahindra tractors. What about Mahindra tractors? Sorry, I did not visit that company till enough. IUG 800 cars. Yes. Mahindra also same. Maybe the same thing. Okay, coming back to our presentation. See, after that production, so you will face lot of issues in production. Lot of issues. So that will be improved in stage 5. Again, in stage 5 improvement, what improvement we have to do? Again, you have to go for conceptualization again. That means that suppose problem is coming, instead of 750 cars per day, you are getting only 500 cars. Then what is the problem? What is your bottleneck? Again, you have to think, you have to improve that, and again you have to conceptualize, again you have to simulate, you have to set up, again you have to go for production. Then again it will be increased for 600. So this means that if you set up a plant, you will not get directly 750 per hour. No, not at all possible. First you have to achieve 200, next 300, next 500, and then 600, and then 750. This is called ramping up of production. Okay. Way forward, stop your robotic suit. Okay. Stably robotic suite under Windows is ideal realistic simulation, offline programming, and remote access to the distant robot. Okay, remote access to the distant robot is out of concept for you. Just I just give you an example. So why this simulation software are required is for offline programming. So how many of you know about Jaguar or Jaguar? Jaguar is just 5 to 6 years per day. That's it. Okay. Offline programming. How do you know about Tesla? I did not met him here. Tesla. Sorry. Um, how many of you know C language? Anyone started learning C language? Sissy have raised hand. Okay, Nitin. Yes, 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 yes. How do you do? I know C sharp. Okay. No, sir, not it. Okay. Little bit. Okay. See, when you learn a programming language, even though you are mechanical, electrical, maybe you are from different streams, I don't know, but it is better to know one programming language. It will be useful in your life at any point of time. So please try to learn one language, whether C, CPP, Java, Unix, .NET, Python, your wish. Okay, so now what is the significance of learning a programming language in robotics? Robotics will always deal with commands what you give, how you program. Have you want to make this path okay? Standalone application means what is that standalone application? Venkata Sai, what is it? Okay, anyway. So when you learn the robotic, when you want to move the robot, you have to give a specified instructions in a specified format, which is based on one language of universal languages. That means whether on C or CPP or .NET or Unix or something else. Okay, so how our robotic suite will help is we can download the machine. You can see physically what is happening in the machine and how it is working in the machine. Okay, way forward. See, this is the programming we will write here. This is the programming we will write here, and this programming will run these two machines simultaneously in this screen. The same thing you can replicate in the production floor also. So this is the advantages. This is the advantages of robotic simulation softwares. Okay, how do you import one CAD diagram or WRL format or STP step format into our software? Is like we have an option called insert CAD. From that insert CAD, we can download step format, IGS format, STL format, and WRL format. In this format, all these formats we can download it, and we can see physically what is happening in the machine. See, we have downloaded this. Actually, we have downloaded this part in a machine, and we have assembled it. These all physical. These all not with physical. These only with software. So here you will have lot of time saved and lot of money was saved. Way forward, we have large number of selections basically. We have TX90s, TX240s, from small robot to big robot. With what the application you want to, based on that, we'll supply the robot, we'll give the robots. And we can download the robots, multiple robots in the simulation software to understand how they are behaving parallelly. Okay, if you don't understand this, please let me know. I will explain again. No problem. We have session up to 12:30 or 12:40. Okay. So basically the thing is multiple versions of the robots can be downloaded in one software, and we can test it how it is working and how it is behaving in one environment. You know, ecosystem, right? Ecosystem means number of machines combined together is called an ecosystem in engineering terminology. Okay, ecosystem, please don't go to trees and plant. No, in engineering terminology, number of machines working together to produce or to serve a goal is called an ecosystem. So in this ecosystem, you can download number of robots, and you can understand how these robots are working parallelly each other by coordinating with each other. This is what the importance of simulation. So these are the robot ranges we have. We have a very small robot called TX. Oh, sorry, TX40 was not given. This is TX60, and the biggest robot is TX200 XL, and these two are called SCARA robots. So all this can be downloaded in one single software called SRS, and you can understand how they are behaving in the ecosystem with your program. Okay, coming back to 3D models, we can download all the 3D models, and standard 3D models also we can download from our SRS, so that these 3D models will serve us as a different parts and different scenarios to analyze the different scenarios also, including including TX200 as well as TS280. That means SCARA robots as well as in 6-axis robots. Okay, we have an option called add here. See, can you see this? We have an option called add. From this, we can download box, sphere, cylinder. That means the basic structures, you can download it. Okay, so once you load the robot, what is the use of loading a robot, and what is the use of simulation? What is the use of simulations? To know how it is behaving and to know how their parameters are changing actually in the production floor shop. So that is what we can do here. See, we have a robot here, we have a robotic arm here, and we have a wall cluster here. See, this is a wall cluster. This wall cluster is placed on the robotic arm, and we are interested to know how this wall cluster is affecting on this robotic arm. Can anybody say how this can be derived? Can anyone? See, we have a robotic arm here. Wait, yes, wait. Okay. How do you derive? Again, please don't jump into your textbook concepts, please. Of course, it's general concept, but okay. See, you have a robotic arm here. See, can you see the robotic arm here? See. Can you see the robotic arm here? Here. On this, we have placed here. Gravitation is CONG. Yes. Okay. On this, we have mounted a valve cluster which is weighted of around 1.5 kg. So you want to understand how this 1.5 kg of valve cluster is affecting our robotic arm. How do you do it? Directional. What is directional here? I did not get you. What is directional? Veeramalla. Yes. Shumukh Veeramalla. Yes. Replace army center of mass, and oh my god, again textbook. Replace army center of mass. Self versus radiation speed arm by simulation, yes, obviously. By checking efficiency of arm. How do you check the efficiency of arm, Abhishek Kumar? Okay. Thing is, when you place anything on the arm, the currents of the motor will be deferred. Create balance? No. So currents of the arm will be deferred. By these currents, we will understand how this arm will be behaved in production floor shop. So that is what we have given here. See this load analysis, this load. Sorry. See this here load. We'll have some load parameters here. See mass, density, volume. Axis Y mass, density, volume. Axis 1, tool 2, dual gripper. So whenever you place something on the robot, currents of the robot, joints of the robot, servo motor currents will be changed. So by detecting the changing of that current, we will understand how it will be affected. Understood? Boring class, right? We will place it with run the program. No. Are you bored? Lot of subject? Yes, sir. You want some break? Okay. So way forward. I got only one. No. Okay. 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 So way forward. So thing is, what is the best thing in our robotic system was, that means robotic suit was, you can move the arm by clicking this, you can move the arm physically. That means that in simulation, robotic arm will move physically and show you how the movement is. This is called Cartesian movements. What is Cartesian movements again? What is Cartesian system? What is Cartesian system? You, okay. Don't say I don't know, please, because you have already studied 2B in your intermediate second year. 2B. While I'm studying, it is in 2B. Mathematics 2B. 3D system, yes. What is the 3D system? But sir, how are we calculating the current utilization in the simulation? Would the require us to plug in? No, we don't want to plug any other machines. It will compute automatically in the system, automatically in the software. That is why we are using the software. Imaginary axis XYZ, yes. XYZ is a Cartesian system. XYZ and A, what is it here? No A, no 4 dimensions, only 3 dimensions. If you have 4 dimensions, then you are God. Who is this? Tarun Venkat. If you have 4th dimension, no, then you are God, seriously. Just like computer calculations, yes, just like computer calculations, we'll have a calculations through inverse kinematics and forward kinematics, and we'll compute the weight, and we'll compute the properties of the 3D geometry. Yes, 3D geometry. Okay, way forward. Okay, now here comes to the main concept called code. So whenever you want to, so okay, you have a controller and you have a manipulator. How do you control this manipulator with controller? First, how do you control manipulator with a controller? By using code. Okay, you have to code it. You have to program it. Yes, you have to code it. You have to program it. How that programming will run? Basically, according to that, your machine will run. Yes, by giving commands, by coding this same. Yes, you are right. So we have a very beautiful language called VAL3, variable assembly languages. This variable assembly language will come to you when you are in engineering third year. You are learning microprocessors and microcontrollers. So don't worry about coding now. So please learn your C coding now. So that will give you a base on coding. So how to move the robot, how to slow down the robot, how to calculate the cycle time, how to do some calculations on it, how to do it. Everything will be done. Everything will be done by this SRS software, and this coding also can be done with this SRS software. But you have to initially know what is C language, and what is the language first of all, and how it will be acting on it. You understand? Application structure. Yes, we can go for anything what we develop will have a structure. So these are the application structures, basic application structures, but it is very advanced concept to learn. Why? Because first thing you have to learn about coding, and you have to learn about what is coding and how to implement the coding in the machine. And after that, you have to go for this application structure. This application structure is not like a simple way of doing that. First, we have to learn what is the system and what is the input output signals of the system, and what is the application, what is the specific task we have to do, and what are the input outputs we are getting from the PLC and going out of the PLC. So everything will be structured in this structured way. That also we can check it in our SRS software. Okay, then please don't ask me what is PLC. Okay, whenever you go for a programming, if you find any mistake, you will go for debugging. Okay, so this debugging facility is also available in our SRS software to understand where the problem is. Same way where you will compile in C, right? How many of you knows? I don't know, but if you go for C language, okay, you will find an option F9 that is called compiling. Compiling means what? Finding the errors. Yes, obviously, sort of, but I don't want to get into technical aspects, but yes, it is sort of finding in errors. So same thing, when you do the programming in SRS software, that means for robotic, Stably robotics, so you will find lot of mistakes while you are doing programming. So you have to run and you have to check, you have to debug the software and you have to, sorry, you have to debug the program and you have to implement in your controller. So once you program here in the system and you have to dump that same program into the controller. So that is called debugging. Okay. Collision detection. So important concept was collision detection. Whenever you are working with parallel robots, collisions are very, very important. Collision detection is very, very important. Why? Because collision detection is the major role playing in this whole world. I think my colleague have explained to you about cobots, right? So we are working with cobots only due to this collision concept. Because if these robots are collided with each other, we will have lot of loss. And if it is collided with human, there is a loss of life also. Yes, once I am working with Nissan, a KUKA robot was pushed against. That means he robot pushed a man against a wall, so he was dead. So robot working is very collision is very important concept, and we can also simulate that collision concepts in our SRS software. See, once this collided, see this was become red. See, can you observe this? This one. So where it is collided, how it is collided, to what it is collided, everything it will be seen. So collision is very important, and you have to be very careful while you are working with the robots. Okay, realistic cycle time. Realistic cycle time is like, what do you say that if you want to do a process, so you have to understand what is the cycle time, what is the cycle time of the robot. That means in how much time the given task is completed. That is called cycle time. Okay, that also you can analyze in our SRS software. We have video recording facilities also. You can record the video, you can take the video and you can send it to other customers who can see that video and we can say their comments and give their comments and give their suggestions. That is called video recording. Remote access not required. Optimized lab. Okay, coming back to this optimized lab, whenever a robot is running, basically this gearbox was under influence of lot of stress. Why? Because it is continuously running. How do you analyze that? How do you analyze the force? How do you analyze whether it is working properly or whether it is working properly or not? How do you analyze? By optimizer lab in SRS software. That means I'm sure that no other robotic company is providing this type of software like optimized lab. Why? Because whenever you run the robot, so that recorder files will be recorded in a software called MATLAB. It is under it is with the base of MATLAB. So it will be kept in MATLAB and it will be analyzed and it will generate a report. See, this is generating a report. That means all the 6 axis, how it is generated, how it is running, what is the torque, what is the currents which is going on. Everything can be seen in that software, in that optimizer lab. Basically, see, blue one is joint 1, green one is joint, sorry, red one is joint 2, yellow is joint 3, violet is joint 4, green is joint 5. Did you see this diagram? So whenever there is a small deviation, then we have to understand, yes, there is a problem with some from joint and we have to reteach it. This is called optimized lab. And we will give a very beautiful report like, see, standard maintenance required. Standard maintenance is required for all the 6 axes, but this particular axis called 5th axis, see, hours of specification, this is required more concentration. Why? Because somehow, somewhere, somewhat we have done mistake. We have to reteach this axis again to make this as a standard maintenance. or else this will be giving a breakdown in a very soon way. To predict breakdown coming in future, this software is required. Okay, this is a very good software. I did not see till now in other robotic systems. Okay, analyzing the report. See, if we analyze the reports, Warmgear is having a very high, what do you say that, high stress and high this one, out of specification. See, standard maintenance is also not there, out of specification. So it is gearbox is under critical stages. You have to understand the dynamics of the gearbox and you have to teach the program and you have to write the program. And maximum value is 141%. So maximum percentage should be only 100%. Not 141%. Okay. Safety principles, yes, obviously safety principles is obviously there. We have basically, I think my colleague have had a talk about cobots. So we have a sensor over here. See, check this sensor over here. So this will be divided into 3 zones. One is this first zone, second zone, and third zone. So when man is standing in this third zone, robot will automatically work with high speed of 100%. When man enters here, it will slow down for 50%. And again, if man did not stop and he entered here, this is a red zone. Robot will stop. This is called SS to stop. These are safety precautions. What we are doing is called cobot. This is called cobot. This cobot will comes with air skin also, as my colleague said. So whenever you touch the robot, it will stop. But here production is very less. Production will be less. Expected production will be less, but safety is more. Generally, in India, Indian industries, they always prefer for production, not for safety, unfortunately. Okay. So this is the brief introduction of our SRS software. If you have any questions, you can ask. After that, we will close the session by around 12:40. We have 8 minutes left. If you have any questions, you can ask. Sir, you can enable the mic. If anybody want, you can raise your hand. Sir will enable the mic, so you can directly interact with me. You have around 8 minutes left. Tejas, boring Tejas?
No, yeah.
No, I see some bored faces here.
Whose face can you see, man, other than mine?
Anyone? Once we make a simulation, how do we exactly create the robot? Robot is already created. We have to just download it. You can raise your hand. Sir will enable the mic. You can raise your hand. Sir, your good name, sir? Ramanidu. Ramanidu, sir, will enable the mic. You can raise your hands. Because writing in chat will, yes, Kuldeep have raised hand. Somebody else.
Kaushal.
Kaushala? Yeah. Kaushal. Yes, Kaushal.
Yes, sir. My question is, once we make the robot in
Yes.
the simulation,
Mm-hmm.
then how do we exactly create the machine out of it?
No, you cannot create machine out of it. You have to create machine in SolidWorks and you have to import that machine in software and you have to analyze it.
Okay, so first we create the machine, then we run it, and then we make changes in the machine.
No, you will not do the machine physically. You have to do the machine in SolidWorks.
Okay.
It's a design software. It's a design and analysis software. You have to do the machine in SolidWorks, and that machine will be imported to our SRS software, and there it will be analyzed.
Okay.
Yes, you need to create an automation system in a CAD file. So then you need to, then we have the robot models in our software. So then we put the robot models to that position and we check the simulation.
Yes.
Thank you, sir.
Any other questions?
Anyone else?
If you don't have questions, once you understood everything, or else you did not understand anything. That is the thing.
Excuse me, sir. Can I speak now? Excuse me,
Yes,
sir.
yes, yes, yes. Venkata
Sir, if Raghavendra, sir. Suriguru
Yes,
Raghavendra.
yes, tell me, sir.
Sir, if the unfortunately robot is not in our control and are anything programming, there is any error in the program or anything else, how
Mhm.
to if the working in if the working is not correct or any problem is, and
No,
at
if
that
your
situation, how did you solve this?
yes, if your program is wrong, it will not even download in controller first of all.
Yes, sir.
If your program is wrong, if you have given any mistake, if you give any command in a unorganized way, it will not even download in controller itself. So we have a option called Wall3 check. You have to check the software and you have to check the syntax and you have to download the software. That means code,
Oh,
not
sir.
software.
Oh, sir.
And while
Coming to the
working,
point of
if the robo has something wrong or the machine layout is changed or some so other than the robot, the external
robotics had one view stored and controller material last month. Excuse me, sir. Robotic hand on.
see there are I will tell you in Mars rovers or some other rovers. So there is a robotic arm installed in the rovers, whereas to collect the samples, there's a robot or manipulator. It will collect the samples, so it will just do minimal activity. So are you
Oh,
referring to that?
or
I
yes,
don't think there is any rovers into asteroid, I believe.
hand on. Can you hurry? Can you elaborate your question, please? I'm not sure. I'm not sure what you're asking about. So basically, rovers in Mars and all will be going for ROS, robot operating software. That is a different thing you have to do. You can tell me something interesting about.
Hi.
Oh, a lot of questions here. Japanese rover and asteroid. Yes, yes. Oh, yes, it will be working on ROS software. It is not like SRS and other Wall3 language. It will work on ROS software, robot operating software. So that's a different concept again.
Yes, we can send robots to space. Not we need to do separate robots, and we can send robots to space. Not the robots which we have actually.
Using Arduino, what are the Arduino robots? Arduino controller. Basically, Arduino is not a robot. Basically, it's a controller, a small controller. Yes, you can also do small application with Arduino robots, but high applications like controlling of big motors and all, you cannot control with Arduino boards. Basically, Arduino boards is having some limitations that we have to respect that limitations. Which language is most important for robot programming? A major language. You just learn C. That is enough. You have to know how to implement the logic. Learn C first. That is very important. Basically, mechanical guys and metallurgical guys, electrical guys, they won't concentrate on C, but C is very important. Any other questions? We'll quickly close our session by 5 minutes because I need to travel again back. Sir, which branch plays key role in robotics technology? Mechatronics or automation and robotics? Can you tell something interesting about resilience? What is this? Can you elaborate, Mr. Satyam Kumar, sorry. Can you elaborate? Tejas, what is it? Do you understand what is it? What he's asking about?
I'm not sure.
What is it? Preservance? Satyakumar? You want me to give the
Preservance to
control?
what?
You want me to give mic? 1 minute. I'll ask sir to give mic. 1 minute.
They can unmute and they can speak.
You can unmute and speak. You can unmute and speak. Sumuk Veermalla.
Oh, Perseverance Mars rover. See, okay, see, that is a
Ah, okay.
rover name, is it? Right. So
Okay,
the
okay, understood. Okay.
rover's name is Perseverance Mars rover.
Yes, okay.
Yeah, so that robot, I mean, the rover has a small manipulator arm, so it is a small robot. That robot application is for just collecting samples and moving rocks, and if there is any hurdles, it will do that thing actually. So then the arm should be pressurized, and there is lot of other technicalities involved in taking the robots to space. Actually, there are very few companies who do that, and NASA, it is their own NASA's indigenous technology, which is done by JPL, Jet Propulsion Laboratory. So yes, robots can be sent to space.
They are designed to set the space, no problem. And these are
Can
controlled.
robot? Yeah, Rohan.
Yes, and these robots are indigenous from the NASA, as my colleague said. And one more thing, the operating software is ROS, and it involves AI and artificial intelligence and some
Machine
sort of,
learning.
yeah, machine learning and deep learning also involved in that. So for that one, again, you have to learn Python, yes, Python languages also. What is it? Programming? Somebody have asked some question.
Mini projects.
Advantages of PF means? Advantage of PF using Val3 and Stably applications. It is OS say C, CPP, Python. Adarsh, I did not understand your question. Can you repeat it again? Can you unmute your mic and can you ask?
Yes, morning, sir. Sir, my
Yes.
question was like, why would one prefer to program in Val3 and use the Sobly coding IDE over a regular programming language that's more widely available
Flex.
in other companies, like
So
C,
why do we use
CPP?
Val3 programming instead of C, CPP and Python, right? That is your question, right?
Yes.
See, every company have their own footprints. They want to go for their own footprints, right? They cannot use
Okay.
open sources. They cannot use open sources like Python, C, CPP. No, they can be used, but every company and everything will have want to have their own footprints. So that is what we are following out. Val3 is our own product. We have developed the Val3. So we want to control our robots with Val3. Yes, we can control robots with Python also. ABV is controlling with Python.
Okay.
Any other
Thank you.
questions?
Yes, there are many robots which can be done by Python.
Yes.
The roots of SRS comes from Unimation, so we have kept the roots still intact from Unimation company which we had acquired. So from
Exactly.
there, so we have developed the programming language and made it more flexible. So to different programming environment, it needs lot of things which takes place either in software side, in terms of investment, in terms of understanding, because there is already a lot of robots installed all over the world. So if you introduce a new software, then you have to educate others also to learn that software. So that's why we are editing and we are maximizing the productivity of the existing
Right.
program rather than doing it with a new program.
So what are the mini projects on robot that can do? You're talking about industrial robots or what? So by if you use this software, you can do n number of mini projects like path optimization and study of robots,
Yes.
study of robots in machine. Everything you can do it in mini as a mini project. You can use this software as educational purposes. That is what our main motto is.
Yes.
And you can learn the programming.
So
You can
you
learn
can
the programming.
suggest your college to get the software from us, and then you can use this as a simulation tool and programming tool to whatever mini projects you are doing, and then you can download the data and implement it actually. So this will be a good programming and simulation software for you to guide you on your projects. So this is a good tool we would recommend also. And if there is any doubts, we are anyways there to help you and support you on that. So yes, you can
So
ask your management to get this software from us.
preparing robots. This guy is, sir, what is the role of Triple E students in preparing a robot? So boss, I am also Triple E from BTech from Triple E. Yes, Triple E Main content, see, basically the thing is, Triple E plays a very important role in doing robotics. Basically, we are the manipulators. Basically, CPU, CSE guys will program, that is the brain. EC guys will communicate with different sensors, like our eyes and nose or something else, tongue or something else, and our legs, hands, everything will be controlled by only Triple E guys. That is motors. That can be done by our Triple E guys. That is the importance of Triple E. What can we expect the future of robotics? What can we expect the future of robotics? Humanoid robots will take the control here. Don't worry. Mission Impossible 2. What is it movie here? What is it movie? Mission Impossible or what? What is it? Arnold Schwarzenegger.
Terminator.
Yeah, Terminator. We'll come to that concept later on. Don't worry.
That is far fetched, but yes, we would evolve in the products which we sell and also the software. So there will be more improvisation in the software so as to become more flexible. The product wise, yes, there will be a generational change. So yes, it's
Somebody is talking
so
something.
it's alright. Any questions, guys?
Upcoming robots.
Mohan, in terms of career, also we can give a few.
Yes. See, basically,
Points.
what we are facing was programmers
Because
and
all are
application
mechanical,
engineers.
so yes.
Yes. So basically, the thing is, whatever the branch is, mechanical or electrical or some computer programming or something else. But the thing is, we are facing lot of issue with programming guys who are available in market now. We have lot of projects are coming up after this lockdown, but we are in lack of manpower now. Manpower are available,
Yes,
but the thing
engineers
is,
are less.
yes, engineering graduates who can program the robot are very less now. Especially our sort of robots like what do you say that Stably and ABB, the programmers was very less. So we recommend you to understand how this programming, how these robots are interfaced with PLCs and how these PLCs are interfaced with other actuators. So that will be very good career option for you for the people and people who are preparing for civils and all. Okay, these are all nonsense for you, no problem. But who really want to come for engineering sector and who want to explore what is going on exactly in automation and what is going on exactly in production. So please try to learn the softwares. Mechanical guys, I would recommend you to learn one software. That means one programming language. That is very, very important. Because being an electrical guy, I did not focus on C, but later on we have learned the things because it is very, very important. Thank you, sir. Okay, you're asking me to go out. Okay, very good.
Sir, excuse me, a small question, sir. Small question, sir.
Yes. Tell me.
We have to learn a special course for robots. Or our studies are enough for preparing any robot, sir. We have to study a special course or anything else for the preparing a robot.
This is a tactical question I have to handle. Basically, the thing is, no, your basic engineering knowledge will lead you to basic robotic design, no problem. But if you want to build an advanced robots, then you have to learn other courses like artificial intelligence and machine learning. You understand my answer, right?
Sir. Yes, sir. Thank you, sir.
Okay, Terminator. Anything else, guys? It's almost 12:40. Last five questions. Sir, what is the estimated IQ of the robot?
It's based on the engineer's IQ, yeah.
Yes. Yeah, that's a good answer. Based on engineers who developed it. Sir, what was the learn for making humanoid robots? Machine learning and artificial intelligence, AI and ML. It was the
Yes.
course you have to learn for making humanoid robots. But yes, this is also a very booming career. You have to really concentrate on humanoid robotics and this one. Very, very booming career. We are in short of humanoid this ML and this one. Is BTech is enough? That you have to decide, Suman Kumar. That you have to decide. Is BTech is enough? I learned this from MTech. I don't know about you. Sir, what is Bob and Haley's Facebook experiment.
I think you are not aware of that. So, Bob
Yes,
and Alice. See, Facebook does a lot of machine learning and artificial intelligence activity, right?
yes.
So, they have gone into numerous test experiments regarding all these prototypes. So,
With your,
it
what
is
are the
still experimental stage. So, I don't think that can be compared to industrial robots.
here is an interesting question. Others, sir, what are some examples of what we are using robotic arms where hydraulic and pneumatics can do the job? Others, can you unmute your mic and ask your question again? Please, I think it's an interesting question I have to answer.
Sir, I'm trying to understand where you would use arms instead of normal hydraulic systems. Scenarios where hydraulic systems won't work and arms will. Like for moving
Basically,
objects, we can just use hydraulics. And you said making robotic arms is more complicated, right? So why would we make arms in the first place?
it depends on the application. Your good name, please. Others, right?
Adarsh, sir.
Yes,
Yes, sir.
it depends upon the application what you do, Mr. Adarsh, basically. So some integrators, some applications are in such a way that it should be only handled with robotics. Let us suppose pharma. We cannot use hydraulics because hydraulics may contaminate everything. It is with oil, right?
And you
Yes.
will
So
not get
in the,
accuracy in hydraulic and pneumatics. Do you think you will be able to get microns of accuracy in pneumatics and hydraulics? I don't think so. So electronics with motors and gears, we will
yes,
be
yes,
able to give you 10 microns of accuracy. So in that only you can initially understand that minute level of repeatability and accuracy we provide. So that is where our
yes.
systems come in, where it's
Like
just simply
surgery.
handling.
Wow.
Sorry,
No, no,
I
please go
didn't
on.
hear you.
No,
Go
continue,
on.
continue.
Yeah.
Yes.
Like surgery, we need small arms in
So
that.
this is small arms.
Surgery.
Yes, we have small arms as there are surgical robots as well. So we are working on it, and we have
Yes,
robots used for surgery also. We have done also in terms of surgery and patient care market segment. So that is also into R&D where, so see, if you are doing surgery with robots, you need the medical certification and all that. So in people who are doing R&D and testing,
stitching. Stitching.
it's already a lot of surgical applications, whereas in India, it is not yet recognized. So it has to be patented,
In
and
India, yes, it
our
is highly
aims
advanced.
has to approve. Yes, aims have to approve robotic surgery because if human error in surgery, then the human has to take responsibility. In terms of robotic surgery, there is no loss. I mean, there is no law where you can if something happens while robotic surgery, so there is no law which can prevent or do this. So the laws is only not created, so it is still on the process.
Last two questions, please.
Yes, stitching robots are there, so it is a small minute robot, so that doesn't have to do anything with industrial robot.
What is the stitching
You can see
robots?
a lot of see, there is a small wire type of robot where it is used inside your
Yeah,
heart or
okay.
whatever item. So it can do stitching. So there is a camera element also where it can see accurately, and they can do stitching. So this is just small manipulators, very tiny manipulators. It's a miniaturized component. So
Yes.
yes, robots can be
It
used.
comes.
That
It
humans
comes under
will handle.
microelectronics.
Yes, human will handle that. Yes, humans will handle that. Robots will not do it automatically, and no robots can do automatic surgery. Humans has to assist the robots for surgery. And guys, in terms of a career, see, as you are mechanical students, you can learn programming to do programming of industrial robots. You can get into PLC programming, electronics, and that sector as well. And also, as a mechanical engineer, you would be having a lot of knowledge into CAD, AutoCAD, and also other simulation softwares. So you can do designing and designing of the system also. I mean, the CAD designing of the system, automation systems also CAD designing you do. Yes, there are different types of careers you can choose from a robotic perspective. So it is up to you on what you are interested and what you can do. So based on me and Mohan, we would suggest you to go for software, because software is one part where you can literally get more flexibility in doing what you can. So in terms of hardware, there is not much limitations, but in terms of software, there are limitations. So software can be upgraded drastically. Hardware, it takes a generational change. So that is what I believe. So if you want to have a good career in robotics, software is good. Design also can be done, and PLC programming and other things also can be done.
Japan is number one technology
So
instead of
yes.
India. Why Japan is number one in technology instead of India? Japan will follow the rules here. India will not follow the rules. That's why. This is the main reason. Yes, yes, yes. Oh, don't laugh here. Here, I'm true. If you want to go right
No
side, you have to
comments.
say left side.
No comments.
What is it? No comments. No, I have been to Japan. Yes, yes, they will follow the rules. I met some Japanese people. Yes, they will follow the rules. Means if 9 o'clock means 9 o'clock, that's it. 9:15 is also wrong. 9:01 is also wrong for them. For our Indians, 9:15 is okay. 9, no issues. So people are going to they ask me if I say 9 o'clock we have to meet. They ask me Indian time or German time. So these
Yeah,
are
see, in
reasons.
terms of Japan, they have good healthcare systems and they are able to take care of themselves. So the extra money which is generated from their government, it goes to R&D. So in terms of our government, it goes into space and they are given other R&D, but then they don't encourage private investors for R&D. Actually, they don't
Come on, you're very support to answer Tejas. Come on, you're very support to answer Tejas. Yes. Okay, what is meant by manipulator? Robotic arm is called manipulator. Ummidi Kiran. Robotic is manipulator.
Manipulator is something which you cannot do, or which you can make something do, is called
Yes.
manipulator. You are manipulating something to do something for you.
Yes. Any other things? Thank you very much, guys. Thank you very much for your patience and all.
Yes, and you have been an absolute good audience and students for us. Thank you so much. So we are intrigued by the knowledge which you thirst, and we are intrigued by your attention and support. So please get to know more knowledge. Yes, try to get as much as knowledge. Try to see more videos. Try to learn softwares by yourself. Now all into digital learning platforms, so everyone is accessible to everything. So it is based on your own interest, on what you want to become and what you want to pursue. Thank you so much. Thank you for giving this opportunity, and thank you for participating also. I would like to thank NIT AP College, Veeresh sir also, and Dean sir also. And I would also like to thank my colleague who had traveled all the way to college and be with you among guys and then discuss there. So thank you everyone. So it's been an amazing session. So hope to continue if you have any doubts. And requesting all students to suggest your management to get this software, because this software also can be network usable. So once this is connected to the server, you can use the software from home also using login details. And this will be useful for you to program, simulate, and check your systems. And this is so essential for anything you do with robotics. So thank you guys. Thank you so much. Thank you.
Can take over.
Thank you very much, sir. So to join with us, and we are very happy. So you are to be the part of this induction program for the first.
Sir, you are muted. So we are not able to hear you, sir.
Sorry. So thank you very much, sir. So to join with us, and we are very happy to you are to be the part of this induction program for the first BTech batch 2020 to 2021, and you have delivered a wonderful talk on stable robotics. And thank you very much, sir. And you have given a lot of useful information about robotics to our students. Thank you very much, sir.
Thank you all. Thank you everyone. Thank you.
Yes,
Mohan.
guys.
Thank you, sir.
We
And
hope we will meet
thanks
again
to Veeresh,
with
sir.
our products as well as our classes again. We hope. And thank you very much for your patience. And If at all, if I answered your questions, yes, very good. If I did not answer your questions, please talk to my colleague, so he can
Yes, if
answer
you
you
have
better.
any
Right?
doubts,
Thank you
then
very much, guys. Signing off.
you
Mohan Trivedi,
can.
bye bye.
Yes.
So dear students, we will meet.
Yeah. If you have any doubts, you can check with your
3
management.
p.m.
Thank you. Thank you. Thank you, everyone. Thanks.